Is $200 the new incentive price for new uranium production to come online? I think that's a little high, but Malcolm, I know you're kind of in that camp or maybe even higher by now. So I want to hear your thoughts on that. I also want to know what in the world just happened with the 3 Mile Island nuclear power plant because my Twitter feed just everything was about that news. So big news. Why are also 14 major banks pledging or major financial institutions, whatever they're pledging support for nuclear? Apparently, that's important too. You can explain to me how that's important. I also want to talk about what's going on with the Sam Altman supported SMR company. I believe it's called Oklo, and just SMRs in general. And probably I'm going to come up with 50 other questions to discuss here today. So I hope you have 4 hours to talk to me here, Malcolm. But then right after this, for people listening, I also have Prismo Metals. They're going to join me for an update on what they're doing with their projects in Mexico, as well as when we're finally going to see some copper drilling on hot breccia. So I don't know how long this energy transition talks episode will be, but it's not going to be short. So buckle up. And now, Malcolm, you've been in a pod before, so no pleasantries needed, I suppose. But just briefly for new listeners, Malcolm is an English bloke who works in the Canadian nuclear industry, and he's technically not a nuclear engineer, I suppose, but he's educated as one, and he's been working with and around nuclear energy engineers for and nuclear energy for over 50 years now, I believe. So I just treat him as if he is one. So yeah, Malcolm, thank you for being here and taking the time to chat. But I want to jump right into this because this Microsoft deal for the 3 Mile Island nuclear power plant really caught the media's attention. And you messaged me to tell me that a lot of people are misunderstanding what's happening. So what's really going on here?
Well, there's a couple of things. I mean, this is a huge deal. This is $16 billion over 20 years. So 800 million bucks a year is the revenue that Constellation Energy will get from this deal. They're prepared to put in $1.6 billion of their own money first to restart 3 Mile Island. Yeah, that's three, TMI 1, which is the operating power plant, shut down in 2019 because it wasn't they were losing money. Basically, they couldn't sell the power into the grid for more than it cost to produce it. So they shut it down for financial reasons only. That's the only nothing technical. The reactor was running fine. Now, I should point out TMI 1 was built in 1974, so it's 50 years old. So that's a very significant thing. That means Constellation Energy is prepared to put in the money into an older nuclear power plant to bring it up to modern day standards, and that is not cheap. That's why it's cost 1.6 billion to do it and to bring it back online for one customer, just one customer. They're not selling this to the grid; they're selling it to Microsoft. Now, how that's going to work is intriguing because the reason why AI or data centers, not necessarily AI data centers in this case, but Microsoft's data centers require power 24/7. Not only that, they require good quality, good high quality power 24/7. In other words, they can't tolerate voltage reductions, they can't tolerate frequency variations within certain limits. And that means that you need a very reliable, very stable supply of electricity. That's not what you get from solar or wind. So the fact that Microsoft has decided to go for a nuclear power plant and 3 Mile Island with all of its history to boot. I mean, you've got to look at the optics of that for Microsoft. They're not just going to any nuclear power plant, they've gone to the site that had the accident. So, they've obviously convinced themselves. I mean, Microsoft engineers are not stupid. These are clever people. They know what they need in terms of power requirements. So they need a reliable, constant source of power. Now, the thing that's concerning me a little bit is nuclear power plants are very reliable, but they don't operate 100% of the time. You have to refuel them. So, in order to refuel them, you've got to shut down 3 Mile Island for a week or two to refuel it. So, what does Microsoft do when that plant is shut down? That means they need two of them, not one. They have to have something else running when 3 Mile Island is out for maintenance or whatever. They're not going to shut down their data center. They can't. That they shut down these data centers, and you know chunks of the internet disappear. Their cloud computing capability disappears. So you can't shut them down, which is why they've gone to nuclear. But
Hmm.
I'm very intrigued to understand how the backup power supply is going to work, because this is a huge power plant. I mean, this is
Yeah.
nearly a thousand. It's eight. What did I say? It was 895, 837 megawatts electrical output. So to produce that with something else, it would have to be probably gas. That's a big power plant. So you're either getting it from the grid, so that this is the backup power supply to TMI one when it goes offline for maintenance, which it will. They refuel every 18 months or so. The older ones refuel every year. So depending on what fuel configuration they install in 3 Mile Island, then they might have to have an annual cycle, fuel cycle, refueling cycle, or they might be able to go to 18 months.
Hmm.
They've got to get licenses to do all of this stuff, of course. The plant is 50 years old. It may have a license to run for 60 years, but that only gives them 10 years. So this is a 20-year deal. So they've got to ask for a license extension, lifetime extension on TMI1. So all of that's got to be done before this deal, actually starts to work. The other question I had for Microsoft is, where is this data center going to be? Is it just 3 Mile Island putting power into the grid? They're on the PJM network down there. So are they going to put power into the grid and draw off the grid? That's a very big interconnection. 3 Mile Island has that. So are they going to put the data center nearby on 3 Mile Island itself, or somewhere close by? So those are questions that I would like to have answered. I don't have the answers to them right now. But the point is, this is just one data center, and this is a conventional data center. I don't think this is even an AI data center that Microsoft is planning. So, it's consuming the entire output of one nuclear power plant. Um, so, this is a pretty big deal. Now, I'm sure that Microsoft has looked at all other alternatives. They're very smart people, as I said. So they've looked at producing this from wind and solar, and the land requirements are just colossal
Hmm.
to replace that amount of energy with solar and wind. It's not that it can't be done; it can, but it's going to cover huge amounts of area.
Hmm.
So to have a commitment by two major companies to drive data center electrical consumption with nuclear power is a very, very big deal. Basically, it says that there's huge money. What's happened with the deal is that now you've got two major industries joined at the hip financially, because Microsoft needs reliable electricity for its data centers. Constellation Energy needs a reliable consumer, a steady consumer for its output. So that marriage is one that is going to work very well, I think, for both parties. I think it's a genius deal, really do. For the nuclear industry, I've never ever seen anything like this. In my wildest dreams, I would never have expected the power industry to be so closely linked with the computer business.
Hmm.
So that's the big deal that I don't think people are quite understanding, because this isn't just one company doing this. This is all of the big companies, Meta, Google. I haven't heard anything from Apple, but I'm quite sure they're thinking about it, because they have to. They have no choice but to
Yeah.
get into, and they know as well as everybody else does that to do this with other power supplies, you can do it with coal, and you can do it with gas, and you can do it with oil, but these are companies that don't like that way of doing business, so they're not going to go to those power sources. That leaves solar and it leaves wind, and
Hmm.
they can't do it. They can't produce the power quality, and they can't produce the the reliability that you need for these data centers. So that means that, as I said in the email there, when Mr. Reality meets Dr. Physics, then, that's when the fireworks start. And that's what you saw. That's exactly what happened. Now the reality of producing reliable electric power has met, the reality of the physics of actually doing it and the
Hmm.
engineering required to do it. So, to me, for Microsoft to pick 3 Mile Island, I mean, it didn't have many other power plants to pick from. There's Palisades and a couple of others out there, Dwayne Arnold, but there are very few that it could pick from. So, maybe half a dozen at the most.
Hmm.
So it's
Well, but
very
I want to talk about that
intriguing.
actually. I'm sorry for interrupting there, Malcolm, but
Oh,
that's exactly where I want to take this because I understand it is positive, but I'm also wondering about the risks of this whole thing. And like, well, what is really the reason behind them picking the TML for this specifically? I mean, obviously, this site has a lot of historical baggage. And it was also, again, if I understand correctly, based on what you just told me, it was shut down due to poor economics. So, do you think that's a
okay.
risk from optics perspective, like from a public perception standpoint?
Yeah, I do. I'm sure Microsoft considered that very carefully before doing this deal. I mean, this is not a small deal. They are committing to take this power for 20 years. That means that TMI1 has got to be running for another 20 years. There's risk there for sure. Can it be? Will they get a license to run it for another 20 years? I think they will. The US NRC has, in fact, relicensed a lot of power plants for up to 80 years now, and this will have to be one of them. So, if it's licensed for 60 years now and it's 50 years old, it's got 10 years life left on that license. So, in the next 10 years, it needs to apply for a license to go to 80 years. So, that's part of their refurbishment. I'm sure that's what they'll be doing, is bringing the plant up to standard so that it can go to 80 years.
Hmm.
Which is more than feasible. PWRs are, well-built plants. TMI1 is, um, but there are very few of these plants that are shut down because of economics. As I said, Dwayne Arnold, Palisades, Holtec had a complete about face. They were going to take that unit to pieces and decommission it. And now that they've realized that there's a huge economic benefit in putting it back into service. So Palisades hasn't got a deal, I don't think anyway, with a company like Microsoft, but certainly on the cards um, to do that. And you've got Dwayne Arnold and a couple of others. Now, the other thing that intrigued me was when the big boom in nuclear power occurred in the 70s in the United States, there were a number of plants that were under construction, and then TMI happened, and many of those plants stopped construction for various reasons. Watts Bar in TVA was one. They actually, I think it's the longest construction ever because they stopped construction and then they restarted construction to bring it online. So TVA now has Watts Bar back online. 2 units there, Watts Bar 1 and 2.
Hmm.
But TVA, for example, already also has other power plants that they didn't finish. Belafonte is one of them. So there are dotted around the United States, probably about 20, I'd say. Correct me if I'm wrong on that, but I think it's about 20 or so nuclear power plants that are in various stages of construction. There's no reason why they can't be finished, and it would certainly be cheaper to finish them than it would to start from scratch because you've got to license a new site, very expensive to do that and time consuming. And AI doesn't have that time. That's the other critical thing about this Microsoft deal. They want that power really quickly. AI data centers are not going to wait 20 years to build a nuclear power plant. They just won't. Because if they do, then the Chinese and the Russians and other countries are going to overtake the US. So there's a major time problem here. The US needs this power really, really quickly. sometimes I was quoted as 2029 is when some of these data centers are required, need this power. That's like tomorrow in nuclear timescales. Nothing happens in 4 years in the nuclear business. Yeah, it's one of the reasons I keep harping on about being patient with the industry because it moves at a snail's pace. It always has done. Now it's been asked to move at a very, very rapid pace. And that kind of leads me into the second bit, which I wanted to talk about, which is the the OpenAI request to Biden for 35 gigawatts. This is one company, OpenAI. One company wants 35 gigawatts. It wants 5 to 7 AI data centers of 5 gigawatts each. I mean, that even puts the Microsoft deal in, pales into comparison to that. Where are these plants going to be built? If they take power off the grid, that amount of power off the grid, somebody's lights are going to go out. You can't do both. We hardly have enough power to meet the requirements now. So now you're going to stick 35 gigawatts of demand, let's say 25 gigawatts on the conservative side. You're going to put that amount of power demand on a grid. That's a quarter of the US electricity, nuclear electricity production,
Yeah.
just in data centers, just in one company's data center. So, when you add Google into that mix, you add Meta, which has been fairly quiet recently, and Apple, all of those companies, all put in data centers into the United States. This is going to be the power consumption of the entire nuclear um, grid right now.
Hmm.
And, we've got about 100 reactors, a little less. So 1,000, roughly 1,000 gigawatts, 100 gigawatts, sorry. And you're talking about increasing that in 4 years to, by another 25 or 35 gigawatts. That's a tall order, really big tall order. So how is the industry going to do that? And that goes back to what you said earlier. In order to do that, and it's possible, it's very possible. We did it before in the United States and around the world. Nuclear power plants were basically at the production rate of what China is now. So it's quite possible to do it. There's got to be some major streamlining of nuclear regulations, which are onerous right now. And we have a lot of interveners and all of those things, which is good, but the Chinese don't have that, so we're already at a disadvantage to the Chinese. The
Hmm.
Chinese do a fantastic job of doing what they say they're going to do, and they're very good at it. They're building, I think, about 20 odd under construction in China simultaneously right now. That's a huge undertaking for any country, and credit to them. I mean, that's where the US was in the 70s. And now we've lost that capability. And somehow, over the next few years, the US and North America in general has got to replace that capability. And that goes back to what you said earlier. Where are the people going to come from? Just the operating people. You need universities churning out people now who have these qualifications and skills. That's let alone all the skills required to build them.
Hmm.
So you need to put the US back to where it was in 1975 in terms of manpower and capability to produce the amount of nuclear energy required to run these data centers. You want 35 gigawatts in 10 years. We've spent the last 30 years putting 2 nuclear reactors online of Votal. So, we haven't got a very good track record of meeting that requirement. So we better get a move on. Otherwise, it's not going to happen. So, but obviously, Microsoft has great confidence that Constellation can do that, and I'm sure they've dug into the details themselves to see how it's going to be done. And Constellation's a big company; it's got lots of resources, and it's already got that expertise. But if you're going to start building, greenfield sites, then you're going to need an awful lot of people, welders. Nuclear welding is a trade unto itself. You can't, you need a lot of skills and experience to do nuclear grade welding.
Hmm.
It's not same as, welding a gas pipe. Not at all.
That's actually
Very
part
different.
of the part of what I also wanted to ask you about because you've obviously looked at the budget for this thing and it's $1.6 billion to restart the plant. What do you think of that? What does that include? And does that amount sound reasonable, or are we going to see cost overruns?
Well, it's been shut down for 5 years. I My experience of plants when they're shut down, and I have quite a bit from the UK, is that when you go to start them up, nothing works right. Almost guaranteed, things won't work as they did when it was running. Why that is, many reasons, but unless they've been doing regular maintenance on it, my guess is they probably didn't. They would have pared down their maintenance requirements because they thought it was going to be decommissioned. So I don't think an awful lot of maintenance work was done on it, but maybe from Constellation can phone me up and say I'm full of it. But my experience of old power plants is that they don't work well. Equipment is older, so it needs replacing. So when they shut it down, you know, pumps and motors. If you go in a nuclear power plant, it's full of pumps and motors and all kinds of equipment, switchgear, all of which needs maintenance. You have to do it regularly. If you don't do it regularly, things go wrong. And this stuff has to work properly. All the safety equipment has to be tested. Um, Huge amount of things have to be done to bring it online. So 1.6 billion doesn't seem unreasonable to me. I think that's about right. It's only been shut down 5 years. So it depends on how much work they've been doing on it for the last 5 years to determine whether or not that's a reasonable number. But the CEO of Constellation, I was listening to him yesterday. He said, they had already ordered some of the equipment that they needed because some of this is long lead time equipment. These big pumps and motors, you can't buy them off the shelf in Home Depot. They take quite a bit of time to design and build. They've already got the design for them, so that's not a problem. But they take time to make. And we've also lost a lot of capability in making these big pumps and motors in the States and in Canada. So we don't have the same production capability that we did in the 70s. That's got to be rebuilt. So this will be an interesting test to see if TMI1 can bring it back online for 1.6 billion. I don't think they're too bothered anyway. I mean, if you're making $800 million a year from a contract like this, I don't think spending another, let's say it costs 2 billion. I don't think Constellation is going to be too bothered about that. Their accountants might get
Hmm.
be a bit upset, but from the business point of view, it doesn't really matter whether it goes over very much.
Hmm.
I doubt they will. Constellation's pretty good at getting things right, so I don't think they're going to have a problem doing it for 1.6 billion. So it seems about the right ballpark number to me. I mean, this is me looking from 1,000 feet up, but I think they are more than capable of doing it for that price.
Hmm.
It depends. It depends if they've got labour shortages and all of the other things that can delay. Always delays are always what costs you the money. In nuclear power, the unanticipated.
Yeah.
But these people have been operating power plants for a long time, so I think they have a lot of experience in putting things back together, making things run right. So I don't think they're going to have too much of a problem getting it restarted. Um, and like I say, this will be the first of many. And how when you start putting many of these on the production capability of the states, that's the reason why Sam Altman went to see Biden. That's the very reason he did that, because this is a huge demand on the whole country's capability. It's not just um, a particular industry's capability. You want to put in 35 gigawatts of nuclear power to to run AI data centers. That is a huge demand on any country. That's the equivalent of what China is doing now. That's presuming they go to nuclear power to do it. There is no alternative. You're dreaming if you think there is.
Well, I do want to talk about the demand and how this is going to translate into the physical market a little bit later on. But what about timeline though? I believe they haven't yet filed an application with the NRC for the restart of this plant, but they've already given a timeline of wanting to restart in 2028. From your perspective, is that realistic?
Yeah, and that interesting. They must. I cannot believe they have not talked at least informally to the US NRC.
Hmm.
Um, that it to make a decision like this and to sign a contract of this size without having some certainty that you're going to get the operating license um, seems a bit far-fetched to me. I'm sure there have been discussions in the background, not a formal license application. That's something entirely different. But there would have been discussions with the regulator um, to see if they had any major issues with restarting 3 Mile Island.
Hmm.
I don't think they do. I mean, it's been running. It's connected to the grid. It's already got all of the safety features that were adequate before. It might need beefing up in that area. Probably, I doubt it though. It's a PWR. They're pretty safe reactors. So, so yeah, I think informal discussions have gone on there in the background. I can't imagine Constellation CEO entering into this agreement without doing that. Um, so, the formal part of it is to make the formal license application, and that requires a lot of work. There's a lot of upfront work that nuclear power plant operators have to do in order to put in make the formal application for an operating license, because it's not just restarting it; it's restarting it um, and doing all the safety testing that you need to do to make sure all of that stuff still works. A lot of work to be done, and new equipment to buy because it's getting old.
Yeah.
Things don't work as well when they're old, as I know to my cost.
Well, it's good to see you have your sense of humor. I don't on my end things don't work when they're young either, but that's a different topic, I suppose. What do you think the timelines are going to be quicker for SMRs though? I mean, just this week we saw some Altman's Oklo get a green light for their SMR, so they're going to be building it, or at least they're going to attempt to build it, but they want to have it operation, or they want to have it built by 2027. Those are very aggressive timelines to me, and they kind of make me feel uncomfortable. What do you think? SMRs by 2027?
Well, we haven't built any yet. This
Yeah.
is the first. So we have no track record. Now the the big advantage of SMRs is modular construction. They can be built for the most part in factories, but that also means that the pressure vessel, for a PWR or BWR design, that they still have a pressure vessel, smaller one, but they still have one.
Hmm.
All of that can be done in a factory, and there's great advantage in doing that. That will speed up construction time because it's modular. I just was reading a very interesting article from Mamoet, who's the crane manufacturer in the Netherlands. One of I think it is the world's biggest crane manufacturer. They've just brought out a design, a new crane that can basically lift an entire SMR module and stick it into its pod. So, obviously they are looking to, and not just for nuclear industry, but nuclear industry generally requires some pretty damn big cranes. And because you're lifting, heavy bits of material up and down, with precision. So you need, high quality cranes to do that. So, with cranes like that available, and modular construction. I mean, these things can be bought on a railway train, or they can be brought on the back of a truck for the most part. But the thing is that it limits the size. In order to do that, they're going to be around 300 megawatts. So you would need three of these for this deal with Microsoft, not one. And there's a big argument that says, well, is the economics of building many small reactors is worse than the economics of building one big one.
Hmm.
And I have I believe there's a good case there to be made. The What we don't know yet is how fast we can actually make these. Can we really mass produce them in a factory? Like 10 a year. I don't know. I think it's possible. Rolls Royce in the UK is gearing up to do just that. They haven't built one yet, but they have contracts with Poland and they've got contracts with the Czech Republic now to build these, plus the UK power grid. So if we're going to go the route of SMRs to meet this AI demand, we need a lot of them. Like if they're 300 megawatts each, 35 gigawatts is what? That's 1,200 of them. That's a lot of reactors. You need a mass production line to be able to produce that amount of that number of SMRs, and we're going to do it by 2027. It seems a bit of a tall order to me, but I really hope the nuclear industry can do things a lot faster because it's very slow. It
Hmm.
always has been. We're building four SMRs here at Darlington. They're the only ones under construction in the world right now. So Ontario Power Generation, actually just down the road from me, is building four of them. I'm not sure if they got the construction license for the first one yet. They're certainly doing a lot of groundwork to install them. But this is very early days in the SMR industry, and I hope it takes off that quickly. I believe there are some really good designs out there, but none of them have actually been operated, and that worries me a little bit because generally, it's one thing to have something on paper; it's quite another to actually build it and operate it. You know,
Hmm.
I've been
Yeah.
through that cycle umpteen times. It never goes according to plan. A lot of the time it does, sometimes it doesn't.
Yeah, it's kind of like my dating life before I found my wife 10 years ago. But do you do you expect to see more of these restarts? And does the US really have enough sites that can be restarted at an acceptable cost on time, where they're going to get public support and so on and so forth?
Well, I think the public view of nuclear power has changed dramatically. That's the other thing that investors in this space need to understand. I've been in this business a long time, 55 years almost, I think now. So over those years, it's gone from euphoria to complete despair, and now it's coming back up into the euphoria phase again. Um, People, I think particularly, your generation, younger generation, are seeing the advantages of nuclear power. In my era, there were a lot of people that thought that you didn't need all this in industry, and people didn't need washing machines. You can use a washboard and all that nonsense. The younger generation doesn't believe any of that crap. It's just people realize they need electricity. And yes, we've had some accidents and some bad ones. I mean, these are not accidents the industry takes lightly at all. Fukushima was a major lesson learned. That just step aside here a minute. When nuclear reactors are built, they're built to what's called design basis standards. In other words, for an earthquake, you look at the typical earthquake that's happened in the region for the last 200 years. All of that data is assembled and you design based on what's called a design basis earthquake. So your designers say your equipment's got to withstand this amount of shaking for this long. And they design it to that. Same with tsunamis in Japan. There was a design basis tsunami. What's the highest wave that we've ever had? And they designed to that standard. It's the standard way the nuclear power plants are built. Unfortunately, we got an event which was beyond design basis. So BYD, as they call it in the industry. So now we have to cater for events that are beyond the design basis of the station. So in the event that the piece of equipment, say, can withstand a design basis earthquake, what do you do if it doesn't? And that's the epiphany that the industry had after Fukushima. We can't rely on design basis calculations. We have to say, what is the worst that can possibly happen here and plan for it? Not necessarily design for it, but plan for the fact that we might get a 55-foot tsunami next week. How do we deal with that? Well, we don't put the generators under the ground where the sea can get in. That's one thing we do. We put them on a mountain top where the sea can't get. So those are the changes that have been made. So Fukushima really was a watershed for the industry. I would very, very much doubt if we, touch wood, that we'll ever get an incident like Fukushima or Chernobyl again. The industry spent billions, hundreds of billions of dollars in revamping its design calculations and emergency preparedness and other measures in case we got events that were beyond design basis, so that we could cater for everything, basically, which I'm pretty sure we can now. At my home plant down here at Darlington, I mean, they have, done extensive work to make sure that, under every eventuality that can be contemplated, that the plant is safe. And, I live next door to it pretty much, so I'm pretty confident that it will. Otherwise, I wouldn't live here.
Yeah. So you were going to talk to me about whether there's enough sites, enough plants that can be restarted, where this turns into something more significant. A trend that actually changes the supply demand fundamentals of the uranium trade.
Yeah, there are a number of things that can be done. So first of all, there are. If let's go down. Let's talk about the US because it's an industry I know pretty well. You've got currently operating power plants, about 95 or 96, something like that, maybe a little less. Those, in order for them to carry on for another 20 years, they've all got to have life extensions. Many of them have. So we're relying very heavily on keeping the existing plants running. That's to provide the power that they can provide now. There are plants like 3 Mile Island that were shut down mostly for economic reasons that are being restarted. There are a few of those. I think the days of reactors being shut down in the US are over. They won't be. They'll be restarted unless there's a major technical issue. That's something to consider. If there's a major technical issue like something wrong with a pressure vessel or something that can't be easily repaired, then it doesn't rule out having to shut down power plants. But we have a lot of experience in pressure vessels right now, so I think it's unlikely they're going to be shut down for that reason. So the existing fleet is going to carry on, and we're going to see 0 or certainly less than 5 shutdowns in the next 20 or so years. So the rate of shutdown of nuclear reactors in the US has slowed down to a stop, and now it's going up the other way. We're restarting them. When I look at my U308 demand spreadsheet, I didn't take any of that into consideration. I've shut down dates for all of the US nuclear reactors. Now I'm having to revise all that and say, well, okay, what happens if they go on for another 20 or 30 or 40 years? So, that takes a bit of work to do those calculations, but we're getting there. Thank you. So that's the existing fleet. So the existing fleet's got to be kept running. If you take reactors off the existing fleet, then you have to replace that with new reactors. New reactors take years to build. The fastest the Chinese have been able to build a PWR is about 5 years, start to finish, which is extremely quick. Votor took 14 years to build. So we are 3 times longer than the Chinese can do pretty much the same reactor. The Chinese Hualong one is pretty much the same as the AP1000, very similar.
Hmm.
So, comparing like for like, the Chinese can do it in 5 years, we take 14. So something has to give there. Just to replace, if we take reactors offline for whatever reason, then we have to replace those reactors to even meet the status quo, let alone grow. So that's a problem. Reactors have to be built to replace what we've got. If
Hmm.
we want to expand what we've got, we have to build in fleet mode. You can't do it one at a time like Votal. You need to plan for 10 or 20 or 30 of them and say, to Bechtel or whoever, or Westinghouse, build me 10 of those. That's the way you've got to build them. It helps with licensing because then you've only got to license the site, not the reactor, because the reactor's the same. Hopefully, maybe we'll build all of the reactors the same this time instead of changing the design every 5 minutes. There's some value in doing that, but when it extends the time it takes to build a reactor by years, you've got to wonder whether that's really worth it.
Hmm.
A lot of reactors, certainly in my history, a lot of reactors were science projects. You know, the engineers that, thought of a new idea and changed the design so that no reactor was the same. The reactors I worked on in the UK were the old Magnox ones, gas-cooled reactors, natural uranium. Magnox stands for magnesium nil oxidation, which is the fuel sheet. Um, they were great reactors, but they built about 10 of them, and they're all different. Every single reactor was different. You couldn't go from Bradwell Power Station, for example, and go to Wilfer in North Wales and operate that reactor because the reactors were different, completely different. Same technology, but they just changed everything continually. So, the French learned from that and built them all the same, more or less. They built them in series. So that's what has to be done. The US nuclear industry is even going to try to meet this AI demand. It has to go into fleet mode and like now, it has to start doing that. And you need
Hmm.
major contracts with major developers like Bechtel and Westinghouse. So they've got some guarantee of work. They're not going to build factories to build this stuff if they're going to build one off. It's just so uneconomic to do that. In China, they don't do that. They've standardized on one design, way long one, and they're building loads of them. And
Hmm.
that's the way to do it. If you want to cut costs down, if you want to reduce production time, that's the way to do it. Now, the other part of that is SMRs. Can we do the mass production of SMRs in parallel to fleet mode big nuclear power plants? The staffing requirements to do all that is horrendous. We need to be going now, full speed now. I mean, 2027 is like tomorrow in the nuclear business.
Hmm.
We are just not going to get there by 2027. I don't think, anyway. I shall be very humbled if somebody does that, and I will apologize profusely if somebody can actually build one by 2027, and I hope they can. I'm a great supporter of the industry, as you know. I think it's been much maligned over the years, unnecessarily so. But I understand people's fears of it. It's very difficult to explain nuclear power to the average person. That it's a complex business, and for me to say, well, reactors safe as houses, well, that's just me because I'm biased.
Hmm.
And I am, of course. I'll admit that. But that's what we've got to do. I mean, building these reactors and just the fueling requirements as well, which comes back to the investing part of this, which is why we're here. You know, we don't even produce enough fuel right now to fuel our current reactors. There's a shortfall now, and we're going to build dozens and dozens and dozens more. These SMRs, a lot of them use pretty exotic fuel, triso fuel, a lot of them use, not all of them, but some of them do. We're just getting into production with some of those fuels now. Never operated them in a power reactor before, so we don't know. We're hoping, and I'm sure there's been a lot of work done, that these fuels will, in fact, produce the performance that the designers expect. Hope they do. They've been tested in research reactors, but that's not the same as running it in a power reactor. It's completely different.
Hmm. Well, the investing part or the investing side of things is where I want to go into the selfish part, I suppose. But what I really want to hear from you here is what restarting this plan that we've been talking about, the TML of 3 Mile Island, or potentially others. What is that specifically going to do on the demand for uranium in its yellow cake form?
Hmm. Well, there's a couple of aspects to that. First of all, the fuel that was in 3 Mile Island in 2019 has been taken out and it's in storage right now. Um, there is a possibility they could put that fuel back in the reactor. I think it's probably unlikely they would do that. I think they're more likely to have a fresh core. Um, so um, that's a decision that Constellation and their fuel and physics guys are going to have to have. I suspect it would be easier for them to just put new fuel in the reactor. There are advantages in doing that, and that goes back to licensing. They may, to get a longer fueling interval, um, I think they were fueling every year at 3 Mile Island. To go to 18 months, you need more enrichment in the fuel. And that means more U3O8, more enrichment, more conversion capacity to do that.
Hmm.
So if we assume that it's going to be some sort of mix of the two, then uh, they're going to have, say, about 50% of the core replaced with new fuel. If it's 100%, then basically you're restarting a new reactor, which is roughly three times its annual requirement. If you then enrich the fuel, then it's even more. So it's more than three times the U3O8 requirement of a standard reactor. So the depends on the approach that Constellation takes, whether they are going to be able to use any of the old fuel. Moving fuel about after it's been in the reactor is a tricky process. I mean, we're good at it. It's not that we can't do it, but it's been sitting there for 5 years. Its configuration is different. The number of reactor poisons that are in the fuel has changed. Um, I'm not sure whether fuel and physics would be able to determine what where those fuel elements go back in the reactor. It would be a complicated task, not an easy task at all.
Hmm.
Normally, with a running reactor, you have a pretty good idea what you need, and there are computer programs that simulate the operation of the reactor. I'm not sure that they've ever done the calculations where they've taken fuel out, put it in storage for 5 years, and then put it back. I'm not saying that's impossible, but I suspect that it is probably better and cheaper and more reliable for Constellation to buy new fuel,
Hmm.
which adds, a whole reactor's worth of fuel to the market demand. It's like Diablo Canyon. Diablo Canyon was heading into this situation a few years back. Now it's been told to run another 10 years. They had to go out to the market and buy more fuel. I think
Yeah.
3 Mile Island is going to do that. So if it takes a couple of years to do it, that demand's going to hit the market now.
Hmm.
And because they may not bother to do those calculations. I mean, for the cost of the fuel, 1.6 billion. I don't know. Let's say it cost 100 million for the fuel. I think that's pretty high.
Hmm.
It's really not a big deal in a deal of this size anyway. So my guess is they're going to go for new fuel, and that demand is going to hit the market pretty soon.
That's
And Constellation's a big company. It orders U3O8 and it orders UF6 and other uranium products. So it may already have U3O8 in the pipeline to do it, but going forward, it's certainly going to increase the demand. It's the demand for
Conversion
uranium must go up.
conversion is again going up in price, and every time so far when conversion goes up, it's followed up by the spot price going up. So I want to talk about that. But I also want to talk about the supply side of things because talking about these things, I'm actually reminded of something else I saw last week, which was that UR Energy is having some challenges finding experienced staff to work at their Lost Creek uranium mine, which is, but it isn't huge, but it has been producing a little under 3 million pounds of U3O8 per year, I believe on average or whatever since they started it. But the ramp up of that production has been challenging. And so they've revised their production guidance to just under one half of 1 million pounds. The upper boundary is 450 something something. But it's not only
Mm.
UR Energy. Lotus released their scoping study, which was very far from being complete and far from the thoroughness that I typically like seeing in these reports. But it did highlight higher costs. Essentially, that's what it came down to. And those two examples are, of course, not the only ones where labor, supply chains, costs, and so on are brought up as challenges as to why production is not going to come online quick enough. So, what do you make of this here? Are you expecting to see more of this going forward, more challenges, more labor issues, and so on and so forth?
No, without question. There's a couple of aspects to it, or several aspects to it, actually. The first is that many of these mines, if you look at just the mining sector, many of these mines are in the middle of nowhere. You know, I'm sure the people that live there don't think that, but but for the average worker, let's take northern Saskatchewan. It is a long way from Saskatoon, and Saskatoon is an awful long way from the rest of Canada. So these are remote areas. Cameco generally uses fly in, fly out um, staff. So they go, I think it's 2 or 3 weeks on, and then they're back home for 3 weeks. That's the way they generally do it. Not everybody wants to live that life. It's a very difficult life for families. It's well paid, but it's not the sort of life that a lot of people want to do. The average, let's say, City of Toronto dweller, who's a mining engineer, is probably not going to want to go to Saskatchewan for 3 weeks and leave his wife and kids behind. It just doesn't happen. Um, so it does not. There is going to be a problem. Sorry, there's always been a problem attracting people to go and do that type of work. And in order to incent people to do that, the wages are high. So I can't see that changing because it's been like that for 50 years. It's always been difficult to get staff to go to these places. And similarly in Utah and the uranium producing areas of the states, these are not, these are fairly far away from major cities. Not quite as bad as Saskatchewan, but they're in remote places and it's difficult. These are desert areas. They're not very hospitable at all. They're hot, dusty, not very nice places to work in terms of comfort. Sure, the industries have done a lot to try and ameliorate that, but the fact is they are in desert areas, and mining is a hard business. So you're always going to have problems getting staff there. That applies to all mining. That's not just uranium mining. Now you overlay the difficulties of uranium mining because now you need very specialized staff to do this work. These are people that are in short supply now. You're now opening up mine after mine after mine after mine across North America and around the world. The demands on the same people. That set of skills is the same people you're trying to get at. So if Cameco's having problems getting people, and your energy is having problems getting people, when all of the other miners start to come online, when AEC starts at Shooting Canyon Mill and all the others, the same people are going to be required. Where are they coming from? They just don't exist as far as I'm concerned. The number of people in the nuclear business as a whole is quite small. And in these very specialized areas like running uranium mills, that sort of expertise is in short supply. So the industry has a major challenge ahead. And I think what that's going to do is it's going to translate into higher costs. In order to get people to do something they don't want to do, you need to pay them more. So to
Mm.
get people to come out to these areas and work and do under the conditions that they have to work in mines in the middle of a desert, you're going to have to pay people good wages. So that means price pressure on uranium.
Mm.
It has to be. That's without inflation. I mean, inflation, even people, there's been a lot of discussion about, where uranium spot price is going to be. And if you read my various posts, I don't watch that very much, but
Mm.
using it as a benchmark, because it is, I suppose, um, we've been saying, oh, it's going to hit $100, $200 a pound. I mean, if you look at the last peak, which was 137 US a pound, and multiply that by compound inflation, well, you get to well over $200, well over $200.
Mm.
So is spot price going to go there? It's almost guaranteed. I think now the number that's bandied about is $300 a pound. And because the industry is under a lot of price pressure itself, it has to get staff. It has to start up uranium mines that have been shut down for a while, or greenfield sites. Has a lot of capital cost has to be uh, spent, and that's got to be got back somehow. So there's interest carrying costs and all the rest of it. So the price pressures on uranium mines are going to be significant over the years. So just taking into account that, spot price can't stay where it is. At 80, what is it, $80 a pound or something it was yesterday.
Mm.
So that's for tier one mines, that's probably okay. For the likes of Cigar Lake and MacArthur River, yeah, you can probably make money at $80 a pound. If you're going down to the tier two mines and restarting them, like all of the Cameco's mines in Wyoming, uh, Crowbutt, and I can't remember what the other one is, Smith Ranch Highland. Those two plants have been shut down for a long time. It's going to be capital required to get them going again. I don't think you're going to be seeing those producing at $80 a pound. You're going to need more incentive to get them going. And that's the mines that have already been operating. For greenfield sites like Arrow in Saskatchewan, I mean, you've got a big capital cost to get that up and running, and some time, 5 years at least, to get it moving. I mean, they haven't got approval to build it yet. I hope they do, but I'm sure they will. But it takes time, and time is money. Yeah, and in the nuclear business, time is a lot of money. That's the big difference. When you do things that take a long time, the time value of money is higher. So if you take 10 years to build a power plant, you've got to borrow that money for 10 years before you make any money. So all of those things have to be taken into account. And the same applies to a uranium mine. If you're going to build a mine, you need some pretty good economics in order to make it work. Yeah, Arrow is a fantastic mine in my book. When it's built, but it's going to take. I think the earliest is 2028. It's going to take probably till 2030 is my guess, but we'll see. We don't know that, but you know the price pressures on uranium are as bad, if not worse, than the price pressures on every mining organization in the world. You know, it you need to pay people good wages to go to the sites where the mines are. They're not in the suburbs of Toronto, believe me. They're in the middle of nowhere for the most part. So you need to pay people to get there. Like I said, you've got equipment that has to be refurbished and operated. All of those things cost money, and that money has to come from the sale of uranium. Don't come from anywhere else. If you borrow it, you've got to pay it back. Banks don't like not being paid back.
Same thing in my
So,
experience. Yeah. Do you think though that that might be part of the bear thesis? Sounds weird, I know, but give me some rope here. I'm thinking off the top of my head and of my shallow mind, if you will. So this might go nowhere, but everything in the nuclear supply chain seems so complicated. The entire process is not only is not only complicated, but just so challenging and challenged, or as already as is. And then not only labor, but financing, permitting, asset, machineries, pipes, and then conversion, enrichment, restarting the plants, and just a list of challenges, as you mentioned, welders, even the list of challenges from ore to pellet goes on, right? So could this be uranium and nuclear's kryptonite, where eventually it becomes so challenging that the US and other developed nations who have the infrastructure just turn their heads toward, I don't know, say natural gas, which is not as clean, but still not as dirty as coal either. Or, I mean, going back to Pennsylvania, fracking, right? That's still a thing that could ramp up, I guess. So, yeah, could this make a dent in uranium demand? The fact that it's just so complicated, this entire space.
well, it's a very good point. Yeah, we have let the industry wither on the vine, so to speak, over the last 30 years. And there's a penalty for that. And the penalty is that, take my own case. I mean, I'm a case in point. I got my degree in nuclear engineering in 1972. Um, when I left university, I couldn't get a job. There were no jobs in nuclear in the UK because the big power companies, a company called the Nuclear Power Group and a couple of others, um, were just not building new nuclear power plants. They were finishing off the ones they got. There were no new orders.
Hmm.
So, I went into the weapons business. That's what I ended up doing for 6 years, and then I got back into the nuclear power business. So, my whole experience of nuclear has been, boom or bust. It's either going gangbusters or it's not doing anything at all. In Canada, it's been somewhat better, and one of the reasons I emigrated to Canada was that because they have a much more pragmatic, sensible approach to nuclear power here, at least in Ontario. So you can't run industry like that. You have to have steady orders. You have to have build the infrastructure and then continue running the infrastructure, um, building plants or refurbishing plants. And it's one of the great advantages of Ontario, I suppose, is that our nuclear supply chain is the best it's ever been. I mean, we have a different type of reactor here, as you know. It's not a PWR, it's a CANDU. But over the years, to rebuild those reactors and refurbish them, the whole nuclear supply chain has been rebuilt pretty much from the ground up, so that now we have a really, really good infrastructure. So if you wanted to build another CANDU tomorrow, we've got it. We can do that. You can't say that about PWRs because the infrastructure is not there. I don't know anywhere in the United States that can build PWR pressure vessels anymore. They're complicated, heavy forgings that require, a dedicated plant to build them. And I don't think there is a plant in the United States anymore that builds PWR pressure vessels. I think they have to be built in Japan. I think Mitsubishi is the only one that I know of that can build them. So, I'm willing to be corrected there, but I think that is the case. Which brings me to this other major event this week, which is the 14 world banks
Yeah.
have said they're going to finance the tripling of nuclear capacity. To me, that's a bigger deal even than the Microsoft announcement this week or last week. And the reason is that financing has always been a problem for nuclear power because the long lead times of them, um, the complexities of the construction, as you mentioned, these are not simple plants to build. They're complex, very. Um, a lot of licensing issues, a lot of siting issues, many things go into the nuclear power business, which you don't have in other industries. build a gas plant, you don't need to go to the USNRC.
Mm.
You don't need any of that. You just get authorization from the environmental folks to build it, and you go and build it. So there's none of this regulatory lead time that you have with nuclear. So you need to build up that capability. Now, when you put big bucks into things like the World Banks, Jamie Dimon and Solomon, I mean, these guys are big players in the finance world, and when they say they're going to do that, you can better believe that what that means is that there's going to be huge amounts of money flowing into the whole supply chain for nuclear, not just financing the power plants, but financing the mines, the factories, the training programs. All of that stuff is going to get a flood of money going into it, because without it, you can't. Your economy is going to go belly up. You can't. A modern economy is not going to be operating without AI. I was on Chat GPT this morning doing a bit of research, and what an incredible piece of software. I mean, just amazing. It just blows my mind. I mean, I'm not a computer guy at all, but um, you know, to see what it's capable of doing, you know, and the efficiency advantages. I mean, I was able to put together a whole massive information within about 20 minutes, and I checked some of it out, and it was bang on accurate. So AI is the future. If you don't build these AI data centers, then the future is not going to be very rosy, because that's where the efficiency gains are going to come from. So the US needs to build nuclear power plants like they're going out of style, and they need to start yesterday.
Mm.
There's good news coming out of it, but the strains on the industry are going to be huge in the next little while, and on the staff and everybody else that's involved in doing it. Plus, we've got to keep all the existing ones running. I mean, that needs staff too, and we're all getting older. That's the other thing. A lot of people in this industry are quite old. It's not a young industry. Um, Getting better. There's a lot of younger people coming into it, which is great, but it hasn't been the historical way that nuclear's been. It's always been boom, bust, boom, bust. My whole life has been spent in the industry doing just that. Where's the next job coming from? I've been very fortunate. I've never been out of work once, but I've been close a couple of times. But it's been a very good industry for me. Um, I've been what's the word? Very well looked after by the industry. Let's put it that way. And there's a huge future for it, but there's a lot of technical things that will slow it down, and it needs a lot of young people in the business to really push it. We've got a nuclear training university called UIT. What's it stand for? Technical University of Ontario, I think it is, and UOIT. Can't remember what it stands for. Anyway, but they're training nuclear engineers to come and work in the Canadian nuclear industry. But a lot of those programs, don't exist anymore. The program that I studied under, the university shut it down 30 years ago. So it doesn't produce any nuclear engineering graduates anymore. But we need to address that problem, and I don't think we've done a very good job of it in the past.
Mm.
Getting better, but the number of people required is going to be very large. Plus, there's also competition from overseas. You can't look at the US or Canada in isolation. Other countries are, embracing nuclear power. Um, you know, like the UAE. I mean, they've just built 4 units of Baraka. They plan to build another 2. The Saudis want to build 16 reactors. I mean, if you add all of this demand to the demand for staff in technical staff in North America, I mean, you need to start churning out people really quick, because we don't have them. It's not just design engineers, it's everybody: design engineers, operators, mechanics, welders, electricians, electrical design engineers. Vast numbers of people needed. Hopefully, this money this big banks bankrolling it will change that. And that
Hmm.
one of the things I've written about on quite a lot on Twitter is you'll see things move when the big money starts to flow into nuclear. I did a little comparison recently, which was, I think, an eye opener. You know, I looked at the oil industry, which is very large, multi-trillion-dollar industry. And then I looked at the nuclear industry, which is very small, you know, hundreds of billions probably, maybe a bit more. But Saudi Aramco produces 10% of the world's oil, and it's valued at $1.7 trillion, something like that, just under $2 trillion. Right? So they 10% of the world's oil production, and the valuation is, let's say, $2 trillion for argument's sake. You look at Arrow, which is 25, will be 25% of uranium production. That's 2.5 times bigger than the contribution of Saudi Aramco to oil. And it's valued in the hundreds of millions, few $1 billion, not even close. So when the type of money that these banks are talking about pour into the nuclear business, it is going to create a huge increase in value in all of those companies involved, from training people to mining the stuff to processing it. Enrichment plants. We haven't got enough enrichment plants to even feed what we've got now. We're worried that Russia's going to cut us off.
Yeah. Hmm. Yeah.
No, it when you see that amount of money, potentially flying into a very, very small pot. Somebody said to me once, it's like the Hoover Dam going through a straw, and that's a very accurate description. That is exactly how I see it.
Hmm.
We just, the Hoover Dam just announced it's going to pour a lot of money through this straw. Those are the 14 major banks. That's
Hmm.
the Hoover Dam of money. Just said we're going to put money into this to make it happen.
And it seems like the International Atomic Energy Agency agrees with you and with them because they revised their global nuclear capacity outlook by 2050. By 2050. Yeah, I'm almost half asleep. It's late for me. I suppose I should be in bed by 7. But 2050 is what I'm trying to say here. They revised it by for the fourth consecutive time. Typically, they do it once a year. But so they are now calling for a 2.5-fold increase in nuclear capacity by 2050. And of course, again, what you mentioned, we had that big headline about those 14 global financial institutions this week that are essentially pledging support for the call to triple. So they want to triple nuclear capacity by 2050. So this is, and it sounds positive if it actually happens. But I suppose that's the big question there, right? If does that sound reasonable to you, given everything we've discussed today? And are those bullish projections really going to translate into more demand for yellow cake between now and 2050?
Oh, yeah, without question, it has to. I mean, first of all, the amount of electricity that's being consumed is increasing faster than people anticipated. If I was to have been told 10 years ago that somebody's going to come along and ask for 35 gigawatts of capacity off the US grid, I would have said no. That's impossible. That's nowhere near average growth rates of electricity demand. So let's set AI aside. Oh, we're going to electrify all transport. Okay, we're going to build electric trains and electric cars and electric this and electric that. Great. Okay, where does that electricity demand come from, or electricity supply come from? Oh, and we're going to produce hydrogen to replace all the petrochemical industry. Ah, okay, well, that needs another big slew of electricity. Where is all that going to come from? It is not going to come from wind and solar. You'd have to cover half the planet in these things to do it. I did actually do a couple of calculations. I'll share it up with you. I when the OpenAI said they wanted to build 35 gigawatts, I worked that out and what that is in land area. From wind, it would take 9,375 square miles of land to produce that capacity from wind. From solar, it's 1,350 square miles, and from nuclear, it's 54 square miles.
Hmm.
So there's the difference between the two. Yeah, and sure, the wind guys are going to say, well, you can farm around wind towers, and yes, you can. Yeah, it's not that you use all of that land area, but that's the sort of numbers that you're looking at. So if you wanted to produce 35 gigawatts from nuclear, you got 54 square miles. And basically, if you put a nuclear power plant at every one of the existing sites which already has the land, you don't need any, which is
Hmm.
what's going to happen. Right? They'll put those plants at existing sites. So they'll, going back to what we were saying earlier, in the US, they'll keep the existing plants running. They'll restart all of the old plants that can be restarted and provide license extensions. Then they'll go to plants that have been started but not finished. And then they'll go to greenfield sites. That's a sequence that I see happening because they're the lowest cost ways of doing it.
Hmm. But
And
essentially, you
then
do think it's not possible, but even probable that we're actually going to triple or even 2.5 fold increase in nuclear capacity by 2050. You think that's going to happen?
we've got no choice.
Hmm. Hmm.
If you want to get off of fossil fuels, the energy has to come from somewhere. If it's going to come from wind or solar, then you're going to have, massive disruption to the landscape, on a gigantic scale. I mean, this isn't just a few solar panels on your roof. This scale of power production is colossal. The only way you can do it, anybody with any sense of realism realizes that you can't do it without nuclear power. Microsoft has really said that. That's what the point of that whole announcement was. They're basically saying we can't do this without nuclear. So we're going to 3 Mile Island with all its history to do it. That says a lot about where people's mindset is at. The big players in this business. You know, you need AI is going to be an essential tool for modern day life, just like the internet is now. The AI is going to be the core of everyday work for many people. So that takes enormous amounts of energy, and that energy is going to come from nuclear because it has to. I mean, look at France. France is a good example of this. When Macron first took office, he was going to shut down about 30% of French nuclear power plants. Within 5 years, he's now said, oh, no, we can't shut them down. We're going to keep them running forever. And we're going to build another whole bunch of them, like I think 16 of the EPR2 reactors, like 1,800 megawatts a shot. That is a huge amount of power and a big commitment of finance. So when the banks say they're going to bankroll it, the discussions I'm sure that have gone on behind the scenes is that if you don't bankroll it, then Western civilization is going to be dependent on China and Russia, and I don't think people want that. Maybe they do. I don't know.
Hmm. This is
China's
no. Go ahead.
China's approach to it, because they're smart people. They realise that they're in a slightly different situation. They don't have a lot of fossil fuels available to them. They have some coal, they have some oil, but they've realized that in order to provide the backbone to the electricity system, it needs large scale nuclear. And that's why they've invested, hundreds of billions of dollars into it. They don't do that because it's something they like to do. They do it because it's in the national interest. They also know that uranium, you can store enough uranium to keep your reactors running for 10 years in a shed.
Hmm.
It's very high density fuel, so you don't need vast storage capacity to keep the entire country running for a long time. That's why they're building the warehouse on the borders of Kazakhstan because the Chinese the mines in Kazakhstan are producing the yellowcake, putting it into the warehouse there, so the Chinese have direct access to it anytime they want. That's smart thinking, very smart thinking.
Yeah.
because it actually means you're energy independent. And that's what matters to most countries. You
Mm.
don't want to be dependent on, somebody's gas line that runs for 5,000 miles, that can be blown up at any point. That basically shuts down your whole industry. That's what Germany is finding out. But, a lot of countries are going towards nuclear power, not just the United States, it's everybody. Most major industrial nations, the only exception is Germany. But they'll turn around, I'm sure. Their industry is suffering right now. And, report after report saying a lot of companies can't make ends meet there anymore because of the high price of energy. So, wind and solar didn't exactly drive down the price, did it? Seems to have increased it. So now they're in, moving to other countries where the power is cheaper.
Yeah. Well, but look, at I understand all of this is very positive, and that of course, maybe you do have a slight bias, as we all do. We're invested in this industry, but given how positive all of this is, why is the spot price not doing what we're all hoping it would? Or more importantly, to me, why are the stocks still so much lower than their previous peak a few years ago, and definitely lower than what so much bullish sentiment maybe warrants for? So that's kind of where my mind goes with this. Like I'm kind of excited for where nuclear is headed, but at the same time, it makes it puts a damper on my excitement, if you will, looking at my portfolio. So what is happening there?
People haven't realized yet that's what's happened, right? The discussion that you and I are having is not being had by, around most dinner tables in the world right now. So the average retail investor certainly isn't looking at nuclear. There's two aspects to this. First of all, nuclear is a very, very small niche market. It's tiny by world comparison. It produces a lot of energy, but the dollars in it are quite small. So what does that mean? Who are the big investors who buy, millions of dollars worth of a stock? Well, they're the pension funds. They're the hedge funds. They're the mutual funds. Those organizations are not in this game right now. Hedge funds, perhaps a little bit, but none of the others. Pension funds won't touch nuclear with a 10-foot barge pole. My investment manager, I have my own pension plan, and I talk to him on a regular basis. In fact, I've got a meeting with him tomorrow. And I've said to him, well, why aren't you investing in nuclear? And he said, there are other better investments right now. And he said, the liquidity of it is too small for a pension plan. That's why. So if you tie that back to 14 major banks saying they're going to put money into nuclear, some of that money is going to flow into mines, and it's going to flow into enrichment plants, and it's going to flow into the whole sequence of nuclear capability that needs to be built up. So when that type of money starts to flow in, that's when the pension funds and the mutual funds are going to become more interested because it has greater liquidity. Very few companies in the business. I mean, you can count them on the fingers of one hand. The companies that actually make money are Kazakhstan, Cameco, uh, uh, Energy Fuels, and Denison a little bit. That's about it. There's 5 companies that actually make money mining uranium.
Hmm.
5. How many oil companies are there? There's $5 trillion oil companies out there. There's just no comparison. It's a tiny, tiny, tiny market. The retail investor is not interested in it yet, and the big players are not interested in it yet. But that will change. When you start pouring big money into it, it has to change. And that's where you know, I understand people's views. It is terribly frustrating for people to see, all of the positive news coming out, and it doesn't seem to have any impact. Spot price I don't look at, and the reason is utilities hardly buy there. That's not where uranium is purchased. Uranium is purchased under long-term contracts, and that's the number to look at. It's been steadily rising for the last 3 years. It hasn't gone down once. Spot price has gone all over the map in that period of time.
Hmm.
So, and the reason is because it's not where utilities buy uranium for the most part. It's not to say that some don't. They do top up. That's probably where 3 Mile Island may get its fuel supply from, because it probably doesn't have a long term contract to supply
Hmm.
3 Mile Island right now. So it's probably going to go to the spot market. I believe Diablo Canyon did to get its supply. So those are the things that may affect it. But otherwise, spot market is it's an interesting thing to watch, but it's not the one that I watch, which is long term. And the reason that's a difficult market is because it's like trying to see cars in the fog. You don't know what's in these contracts. I've been in this business a long time, and I've only ever seen one contract in my entire life, and under pain of death as well. So they are very closely guarded, and for good reason, because you don't want your competitors knowing what you pay for fuel. You don't want them to know that. That's a confidentiality agreement between you and the supplier. So Comigo or whoever it is who you're buying the fuel from will never tell you what's in those long-term contracts. So it's like trying to see in the dark.
Hmm.
You don't know what's in there, and the price that's quoted is really a guess. It's not. It long-term contract price is kind of an amalgamation of a bunch of bits of information that UXC and the others trade tech put together to determine it. I mean, there's a lot of logic behind it. I'm not saying those companies get it wrong, but I don't think it's a very good indicator of the shortage or otherwise of uranium yet.
Hmm.
But that's changing. These announcements this week are major game changers, both of them, and that is going to have a huge impact going forward. How long it's going to take to do that? It's a very slow business. That's all I can say. It takes time.
Anyone's guess too, but what do you think is causing this disconnect though between spot and term? I mean, is this just normal market dynamics? Is that how it typically goes when
It
you're paying attention to it?
always does that.
Okay.
Always. Yeah, if you look back in history, it's always done that. Sometimes it's higher than long-term price. Sometimes it's lower
So
because there's a lot of things that affect spot price, right? Spot price is, yeah, there are people that trade pounds around, to make a buck or two on a pound. There's not. It's not like there's vast amounts of uranium changing hands on the spot market. Not like the copper market or iron ore market or any of those. It's quite different. So it appears as though people are buying uranium. There's people that put in bids and there's people that put in asks, and that, but that's not representative of actual pounds that move from mine to utility. And that's what a long-term price does. Long-term price tells you there's this number of pounds moving from the mine to the utility.
hmm.
There's all kinds of things go on in the uranium business. There's uranium swaps. People borrow uranium from other companies to be paid back later. There's all kinds of deals like that going on behind the scenes that you don't know about.
Hmm.
The
What?
bottom line is that if demand outstrips supply, sooner or later, it has to hit the uranium price. And what I see with all these announcements this week is it's going to hit the uranium price really hard. I think uranium fuel buyers are going to be very surprised what they see in the next couple of years. I think $200 uranium is definitely, spot price uranium is definitely on the cards, maybe
Hmm.
higher.
But what is it going to take
Because,
to get the spot price moving again though now? I mean, do you think spot has to come back into the mix? Is that the thing that's kind of kick it off? Is it going to be 3 Mile Island well, it's operators going for pounds in the spot market? Well, what's going to get us moving again?
well, um, Palisades needs fuel. They're coming online in 18 months, so they say. 3 Mile Island, again, they're going to need fuel. Or they reuse the fuel they've got. Unlikely, but all of these developments are going to require somebody to get fuel. They either get fuel on the long-term contract or they get fuel on the spot price, spot market. There's only two ways you can do it. You could, like I said, borrow fuel. I mean, that's been done before. Um, you know, you could go to the enrichers, I suppose, and change your enrichment capability, enrichment levels. That's another way of doing it, which is, basically creates more waste, not waste, but residuals from the UF6. But, sooner or later, these companies are going to have to get fuel from somewhere. Even if you borrow it, you've got to pay it back at some point in time. Cameco doesn't produce enough, I don't think, to meet its actual requirements. So it's going to have to get fuel from somewhere. Maybe it borrows it from Orano. I don't know. Lots of ways they can do that. But bottom line is that sooner or later, the demand has to hit the long-term price, and it has to hit the spot price. And spot price will get hit when all the mines are contracted out.
Yeah.
So right now, I believe Cameco has contracted out most of Cigar and MacArthur River's output. Those are their two big mines. What do they do after that? Do they not sign LT contracts? Unlikely. They're going to want to keep in business, and they're going to want to grow their business. So they're going to go to tier 2 assets, which are their mines in Wyoming, and maybe Rabbit Lake. I don't know. Maybe they restart that. Not sure. But or they extend the lives of Cigar Lake. That's another opportunity they have. But sooner or later, there's going to be no more mine capability left, and we haven't got any new mines coming on. The big price spike the last time was caused partially by Cigar Lake flooding, which was a big deal. I remember it very well. And there was a lot of panic because they thought Cigar Lake was actually out of commission permanently. It flooded the whole mine, ruined a whole bunch of equipment down there. It was a big deal. But this time it's even worse because it's not like Cameco very successfully re-engineered the mine, froze the ground, so the water ingress wasn't a problem, and less of a problem. And fantastic piece of work that they did, and they actually brought Cigar Lake back online. Well, the next Cigar Lake we've got is Arrow, and it's 2029. So how are you going to refuel all these SMRs and all these new reactors that are planned throughout the world from no mines? Kazakhstan's not going to do it. That's been the country that's been relied upon. They're certainly going to make some impact, but they're certainly going to take advantage of the opportunity. But this demand that's coming up, there's no way. And that's when it's going to hit. That's when the price is really going to get affected. And all I can say to investors is you've just got to be patient. I know it's easy to say that. And, one thing I've learned over the years is you've got to be patient. And in the uranium business, you need to be ultra patient. It's not like any other business. Not like it at all.
Hmm.
There's a lot of money to be made.
Well, but you look so calm, which is, and I'm saying this as a compliment, but are you not this way? Well, you were very early to this, so I assume you're still in the green. But are you not disappointed? Like, did you not expect this to happen sooner?
That's a really good question. Yes, I did. Yes, I did not think it would take quite as long as this. My timeline was to be out of it in 2030. I think my timeline is now about 2035.
Hmm.
because and I have done very well at it. I was a very early investor in NextGen, so I'm well in the green, and that's not gloating. I hope people don't take that as being I'm better than you because I'm no better than you are.
Yeah.
It's a question of you have to look at all of these events that are going on, try and it's all a moving target. You have to try and anticipate when these things are going to hit. And you can't run an industry that requires a mine product when the mine supply doesn't meet the demand. Either the industry stops or, and the lights go out, as Rick Raw would say, which is a line I like to use because it's a really good one. The lights are not going to go out in North America. And, AI data centers are not going to stop being built. They are going to be built. And in order to build them, you need nuclear power. And in order to make nuclear power work, you need U308. There is no alternative.
Hmm.
So based on that backdrop, that's why I'm fairly calm because I know what's going to happen. All of the, spreadsheets up the yin yang now that show, the shortfall that there is in uranium. And that's before we build any AI data centers. It's before we build any SMRs. It's before we restart 3 Mile Island and all of this other stuff. That doesn't, the spreadsheets I have right now don't even take that into account. Partly because I'm having a hard job figuring out how much SMR demand is going to be. For one thing, the big power reactors I know, but the SMRs, it's indeterminate. So I haven't got those on my spreadsheet, and there's already a shortfall in uranium.
Hmm.
Some people say there's huge supplies of this laying around, ready to be shoveled up and put in reactors. There isn't. That's a fallacy.
Yeah.
So
Yeah.
that's why I'm confident because I know what's going to happen. It doesn't take a rocket scientist to figure it out. If if you don't produce enough silver for the silver industry, then the price of silver goes up until somebody mines enough silver that meets the industry's requirements. That's what happens. Solar panels require silver. Solar panel production doesn't shut down in China. Because of a shortage of silver, they make sure there's enough silver to be produced in order to meet that demand. So that's why I'm very positive about the uranium industry. Frustrating you know as hell, I know, but it is for people that have got in the last 2 or 3 years, maybe that's somebody's using a vacuum cleaner instead. If
Yeah.
people have got into it in the last 3 years, all I can say is, you just need to have a bit of patience, a lot of patience, not a bit. It's a very frustrating industry, and I can't, I can't give people patience. All I can do is give people the facts as I see them, and what's coming is a tidal wave of demand. And if the tidal wave of demand doesn't hit, then something's got to give. Either we don't build AI data centers or we don't use electric vehicles, or something's got to go. Or we
Hmm.
build gas plants. That's the other alternative. I mean, maybe that's the solution. In my view, I think it's going to be a bit of both. I think we're going to take some time to get ramped up in nuclear. And in the interim, we're going to have to build gas plants. But,
But
I'm sorry, in my area here in Canada, in Ontario, I mean, everybody's talking about nuclear right now.
hmm.
We've just finished the refurbishment or almost at the end of finished the refurbishment of Darlington. Bruce site is also refurbishing theirs for another 30 years and expanding the capacity, and they're going to planning to build a third set of 4 reactors there. So everything in the nuclear business in Ontario is just humming along, and we do have the supply chain to be able to meet it, which is a good thing. That's the bit that's missing, I think, in the States at the moment, but it'll get there. The States is pretty good once it puts its mind to things.
Hmm. But in the meantime,
But
you're not making any changes to your portfolio. Like you've not been selling, but are you adding? Are you trimming? Or taking profits? Or what are you doing?
uh, I well, I've been doing two things. I mean, the bit of a capitulation that went on there in the summer, was a good buying opportunity. So I got some few companies there that I like. So I've been topping up on them. Um, but it's not the only thing I invest in. Of course, I mean, to have other parts of the portfolio besides uranium. But certainly the one that has the biggest potential for growth. And that's a thing. I mean, a lot of people are focused just on uranium. If you've read any of Warren Buffett's preachings, uh, his work, that you don't focus on just one area. You look at, he wouldn't invest in uranium because it's too difficult. He wouldn't understand the market. I mean, very few people understand it. But certainly Warren Buffett wouldn't, so he wouldn't put money into it. He likes things like Coca-Cola. Um, so you got to, I think, to be a successful investor, you've got to look at those markets that are unloved, and that's uranium, and it's still unloved by the majority of investors. Most investors don't even know anything about uranium. Now, if you go on the street and ask, what's the spot price of uranium, nobody can tell you. You ask them what the price of gold is, they can tell you just like that. It's a fact. People don't know what uranium is or what it's used for the most part. It's only geeks like me that do, but not too many of us around. So that I wouldn't focus just on uranium. I mean, people have got lives to live, and but for me, uranium is a no-brainer. It's going to make a lot of. It already has made me a lot of money. You know, I bought next gen at 60 cents or something like that. I'm very happy with it. So, um, people criticize Lee Courier, but I can't really criticize the man for making me that amount of money. But not everybody got in at that point in time. Was it a bit of luck? Somewhat. I've been watching them for a long time, ever since they started, actually. And when they found that first drill hole, I thought, holy smokes, that is a drill result I've never seen anywhere before. And that's when I bought just a few months after that. And then the whole series of other drill results came in that confirmed it. And, you know, 10 years down the road, we got this massive £30 million a year deposit. So, will it go up from here? Yeah, for sure it will. No question. I think next gen is a potential buyout target. It's my own personal view. I think the big oil companies are going to get in the nuclear business. When you see big banks doing that, you can think that Exxon and BP and all the other companies are thinking, you know, they used to be in it. The oil companies used to be in the nuclear power business, believe it or not. They were one of the big promoters of it. I see that happening in the next few months, years, maybe. So that's just a personal view.
Yeah.
No facts to back that up yet, but I can see it. I can see it coming. And when those companies start to be bought out, that's when the big dollars flow. You know, I think it's going to cost a couple of $1 billion to build Arrow for an oil company. That's chump change.
Mm.
$1 billion, they'd buy that for that rate of return.
Well, that's part of the
And they
market.
go,
That's the part of the market that you're focusing on right now. Then just developers. You're not going further down the quality trail, if you will, into the explorers, or how do you view them?
oh, I do. Yeah, oh, yeah, absolutely.
Mm.
Yeah, I do have quite a number of the explorers. I mean, they're very low, dollar value for the shares. Penny stocks for the most part. Yeah, for sure. I mean, that category is likely to get swept up in the move to nuclear energy, because they are the people that are the next mines, if you like. the next part of the supply chain. Either they get bought out by the Kamikos of the world, or although Kamiko said it's not interested in doing any of that, I believe that when I see it. They're smart people there at Kamiko. I'm sure they've got their eye on a few companies.
Yeah.
And it'd be foolish for them to say they were, before they actually did it. I mean, that's not the way business is done. That they keep an eye out for potential mines to secure their future supply, because they're thinking 30 years out. They're not thinking tomorrow.
Right. Yeah. Good. But
And
what else is new? What else should we be talking about here? We've gone through a lot. I don't want to keep you all day, but it's we've almost been on for 2 hours. So what else? What am I forgetting to ask you?
uh, what did I have on my list? A couple of things on my list there as well. Oh yeah, one of the things we didn't talk about was new reactors. Um, the If you look at the World Nuclear Association's website and the International Atomic Energy Agency website, they have a thing called the Power Reactor Information System. You're probably familiar with it. If you go there, one of the things that I noticed changed was the number of reactors under construction. It's gone from 55 to 62. So when you see that, that means a large increase in future demand for uranium. Now, some of those are Chinese reactors that are going to be online in about 5 years. Some of them are Russian reactors being built overseas, like AKU and El Daba in Egypt. All of these reactors coming online in the near future require a lot of uranium, a lot more than a regular power reactor, because you're creating a whole new core for that reactor. So those 62 reactors are worth 3 times the amount of uranium that a steady state reactor needs. So when you see that number going up, that means the future demand for uranium is going up dramatically, and that has to come from somewhere. And it's going to come from existing mines, and they're all contracted out. So that's when you see the price of uranium going through the roof. Is when those reactors start to come online. There's four reactors in Turkey, 2 reactors in Bangladesh, 4 reactors in Egypt. The Saudis haven't started yet, but they're going to soon. The Czech Republic has announced 2 new reactors and a whole bunch of SMRs. Poland has just started on its first nuclear reactor. Flamanville is about to start up. That's the French EPR. They built one in Finland, and the Chinese have built 2 or 3 of them. I think 2. So this whole demand picture is changing. I mean, it's high now, and we can't meet the demand with supply. And now we're adding all of this extra demand on in the next 5 years. I mean, where's it going to come from? I honestly don't know. I think there's going to be, my view, I think some reactors may have to shut down because they haven't got enough fuel. Because unless there's some stockpile that I don't know about in the world, then something's got to give. Because you can't, it's not sustainable. The numbers that I've seen are just not sustainable. You can't build 62 new nuclear reactors and expect that supply to suddenly materialize out the ground without building a mine to supply it. And there aren't the mines to supply it. End of story. That's all you really need to know. Not enough mines, too many reactors, something's got to give. When that happens, that's pure speculation. I don't know. I expected it to happen before, but it hasn't yet. But it's going to.
Yeah. And I think the point that you made about diversification was very important too, that you have to be able to afford patience. Like patience is something you can afford or you cannot afford. If you're over leveraged, if too big of a part of your portfolio is in this space, then you cannot afford, then you are losing sleep. If you depended on this thing to pay your mortgage or your rent or stuff like that, that's obviously It's weird to have to say these things, even, but it is true.
It is. Don't do that.
Yeah.
You know, I understand. You know, people aren't in the same position as me. You know, as far as I'm concerned, it doesn't matter to me if the whole uranium industry tanks tomorrow. I'm okay. That's not the case for a lot of people, and I absolutely 110% understand that. You certainly don't want to bet the farm on on this because although it has enormous potential, as we discussed, people have to live their lives. And I don't criticize people for pulling out of the uranium business. Um, to me, I mean, I invest for my sons and my daughter. Um, you know, I have diversified their accounts to make sure that they're not overly dependent on what happens in uranium. But I'm also ready to switch back in when I see the signs that things are moving rapidly. So you have to have that in the back of your mind and in your peripheral vision that yeah, I'm maybe going to move a little bit out of this sector because it's not giving me any dividends, it's not paying me any money, it's just dead money there. I absolutely understand that. Um, if you can afford to, you made a very good point. Patience costs money. It does. I never, it never occurred to me before until you said that, but it does. The uranium business doesn't generate you any money. And if you've got a lot of money tied up in stocks that aren't doing anything or they're going down, you've got to question the wisdom of doing that. And I do not fault anybody for doing that. People, especially if there's any leverage involved, which is never a good thing with stocks. But if you're leveraged against potential of uranium, that's not a good idea. Use money that you can afford to lose. That's
Hmm.
my best advice to people. And I am very enthusiastic about the uranium industry. I have been, continue to be, because the potential there is just, you know, if you get it right and you get the timing right, it's life changing wealth can be generated. It's what happened with Paladin. I mean, it was 1 cent went to $10, 10,000% gain. That's why Rick Rule likes uranium. It's made a shitload of money. And that's why he's enthusiastic. Same reason I am. I made a fair bit of money on the last uranium runner. Um, made a few mistakes along the way, from which I learned. School of hard knocks. But yeah, I mean, don't jeopardize your family life and and your regular life for the potential of uranium. It's. But on the other hand, investors have done quite a bit of research into uranium, so they know the basic thesis. What I'd suggest if you're going to pull out of the sector for a while, just have it in your peripheral vision. Keep an eye on it because if you can get back in when it really starts to move up, then you've got the best of both worlds. You haven't tied up your capital for years and you're still going to make the money. Maybe you won't make the stellar gains, but you can do very well.
Hmm.
People ask me, should I invest in next gen? And I can't answer the question because it depends on people's personal circumstances. You
Sure
know,
does.
if you're a multi-millionaire, put 1 million in next gen. If you're you know trying to get enough bread to make your sandwiches, then don't.
Hmm.
It depends on your circumstances really. Um, people have lives to live, and they shouldn't be focused just on one particular sector of very small sector in the world of investing. I invest in a lot of things, not just uranium. Uranium's probably about, I don't know, 30% of the portfolio right now. It goes up and down uh, as I see things change. But you know, one of the things I look at is other commodities that could be affected by all this electrification business. One of which is copper. Done quite well on copper in recent weeks, and silver, because silver is needed for all of those AI data centers. Most of them have silver or gold-plated contacts in there to reduce resistance. A lot of silver demand, and solar panels, of course. So those two things I've looked at. Not a big investor in gold. Have been in the past, not so now. But yeah, I mean, you've got to diversify your portfolio. You shouldn't focus on just one thing. It's generally a mistake to do that.
Yeah.
The potential is there. I mean, that's all I can say is it's a really, really slow moving business. Nothing happens till it happens. And my whole experience of the nuclear industry is it's slow. If there's one word to describe the nuclear industry, it is slow. Nothing happens fast. Nothing. And if you're expecting it to happen with the speed at which other stocks move, it won't. Not yet, anyway. I think the conditions are there for sure. I've expected spot. I was quite surprised spot market went down. That did surprise me. Didn't go down all that much, but $20 a pound. I suppose that's a fair bit. I'll have a drink here. But you've got to have a long-term view of uranium, and you've got to see all of the moving bits and keep looking at all of those moving bits. I don't tend to look at the LT or spot price particularly. I certainly don't look at it every day. I don't look at the stock market every day. But what I do look at is the big bits that move around. That it's like trying to line up the stars, or the planets. When things move in uranium, usually all of the planets are lined up, and that's what you have to look for. You got to look for, where's the big money coming from? Well, we saw that bit of the puzzle just drop into place this week. That's the big money. Governments are big money. Governments pledging to do things in nuclear means big money. That takes time. That big money is going down this tiny little straw, and sooner or later, that straw is not going to be big enough, and you're going to have the expansion of nuclear power that we've talked about. But it takes a while.
Yeah. Yeah, exactly. This has been a jam-packed conversation, Malcolm. I really appreciate all the wisdom. I'm out of questions, but we should do this more often. And I know we say it every time we speak that we should do it more often. Life gets ahead of you sometimes. So, yeah, I really hope we can do it sooner. But thank you so much for doing this.
You're very welcome. It's always a pleasure. I I guess I got the benefit of being an old guy, and I've seen lots of these things before, and I've seen people get out way too early, and wish they hadn't. Um, I've seen people stay in too long and wish they hadn't. So there's quite a bit of timing involved in uranium, particularly in all commodities, not just uranium. They all do the same sort of thing, the supply and demand. It's just the supply and demand calculation for uranium is so bloody complex. It is so difficult to figure it all out. I can see the average guy getting completely overwhelmed by just the terminology alone. You know, I sometimes, my grandson asks me, what I do for a living, and I'm trying to explain nuclear power to a 10-year-old. I mean, and I'm thinking, I'm using words that he doesn't even have a clue about. What's a neutron? Oh, what neutron? Then I have to go into atomic physics. It, it is such a difficult area to invest in for people. And to a large extent, you're relying on people that are in the business or who know a lot about the business to try and guide you. And, that's really a leap of faith for a lot of people. So when things don't pan out as they, went a little bit of belly up in the summertime there, I can understand people's frustration, and I've had a few attacks there on Twitter, because of my enthusiasm for the industry.
Mm.
But it will happen. There's no question in my mind. It's bound to happen. It's when it happens is got to be properly positioned to take advantage of it because there's millions to be made, a lot of money to be made, and it will come in sooner or later. Is it going to be in the next 3 months? Don't know. Next year, likely. Next 2 years, getting a bit more certain. It's how long you want to wait and how long the price of that patience is to you. That's a really good line, by the way. I've got to use that as a price to patience.
It's yours for the taking, Malcolm. Do it as you please. I greatly appreciate you doing this. We should do this more often. I'm going to keep saying it until we actually do it more often. But you just have so much good knowledge in you that I want to put it out there and kind of help you put it out there. For people listening, if you have questions, topics, whatever you might have for me and Malcolm to discuss, please do let us know. Put it in the comments below. Reach out to me on whatever you can find me. Send me an email, whatever works best. But Malcolm, thank you so much. We'll let you drop off now. I understand you actually have a life. And I also have someone else waiting to talk to me. And I'm going to have to go into my favorite part of this energy transition talks episode. And that is, of course, the disclaimer, right after which I'll jump over to the CEO barbecue and then talk to Prismo Metals. But there's a warning on your screen right now. Technically, you're obligated to read it, but you're also just better off actually pausing the screen and reading it because this is not just some disclaimer. This is an actual warning. This thing, if you read it and understand it, what it actually means, it might help you not lose as much money or prevent you from making big mistakes, which, by the way, is the norm and should be the expectation in this sector. Losing money, that is. And talking about money, that's part of it too. I'm here to make money. I make money from the existence of this channel and specifically from companies paying for the production of these interviews. Now, in this episode specifically, it is Prismo Metals, who is a paying client of Resource Stocks. So understand that they are probably here as part of their marketing campaign. And just start by understanding that really all company communication. I used to say that most company communication online is marketing. I'm going to go ahead and say that all company communication, online and offline, that's all marketing. This interview, their presentation, them being at a conference, talking to investors, their Twitter account, their news releases, their website, whatever. It's all marketing tools. And although I don't make buy or sell recommendations because in my opinion there's a clear conflict of interest when you do that, many out there will do, and you should be aware of that inherent bias. That's not always going to be clearly disclosed with everyone out there, so it is safer for you anytime you're watching any type of company specific content, including this, to approach it with a dose of skepticism, maybe even consider using your own brain and treating this as marketing. Unfortunately, I'm not a magician. I don't know anyone who's a magician. There's definitely no magicians in this video. So we don't know what's going to happen. We don't know what's going to go up, what's going to go down, or what's going to go in circles. So approach this knowing that there's risk involved. Also, unfortunately, try as I may, I'm not always going to catch all red flags. Yes, this show is called the CEO Barbecue. It's meant to grill the CEO. But I'm not going to catch all the challenges with the companies out there or shenanigans, whatever else it might be. Okay. Although you shouldn't tell my wife this, I'm not flawless. Matter of fact, I still have no idea what I'm doing. And so I also lack experience. And so I'm going to miss things. And this is all to say that you shouldn't blindly trust me or anybody on the internet. You shouldn't rely on one piece of information. You should seek out more information. In addition, no guarantees are going to be made here besides that there will be forward-looking statements in these conversations. That's for sure going to happen. This is going to be a conversation that will be general and impersonal in nature, containing hopes for the future and stuff that may or may not take place, depending on many different factors, both within and outside of companies' control. So be aware of that. Be aware of the inherent risk to investing. Your capital is at risk. You might lose all your money. And being aware of what you're doing. And please talk to someone who's proven to know what they are doing and talking about, like a professional investment advisor, as well as do more research by visiting setterplus.ca, where you're going to find the company's official filings. That's where they are obligated to tell you everything that's going on and maybe stuff that are not in the presentation, stuff like that. If you don't do that, you're highly likely lose your money. Again, disclaimers are on your screen right now. If you don't enjoy losing money, read them and be careful out there. With all that said, though, I'm gonna try and shut up now and actually move into the interview. And I'm gonna have to go to Mexico again because Prismo Metals has started drilling, and there's no need for a fancy intro here because Alan has been on the channel multiple times before, and I'll link the Prismo playlist for anyone who wants to watch my conversations with them or with Alan, and everyone really should, of course. I might be a little bit biased there, but Alan, you started drilling together with Vizla down in Mexico. Planned length of the first hole is 250 meters, and that's only part of a in total what's expected to be a 1,250 meters of this first pass drill program. I see that there's a positive quote from Dr. Gibson, so Dr. Gibson, want to hear from you as well. But talk to me about the reasoning behind doing this hole in the first place. Why go there? Why now? Why start drilling? What are you hoping to get out of it?
But if I may just jump in first, when I expand on the word delay, I have absolutely no objection using the word delay. I think it's important to know, though. I think we felt, as in Prismo, felt that we would get on site and be drilling quicker than we had anticipated. And as we said in the news release. There was additional time because we're drilling off of their property, Vizsla's property, and so we had to make sure that we were trained with all of their safety protocol, environmental, and so on and so forth. And then the type of permitting that they got to drill off their property requires that a lot of the work can be man-made. So, building the pad, movable drill. And so I would say, yeah, it probably took a little longer than we would have hoped, but here we are drilling. And so over to you, Craig, and yeah, to answer the question, why this hole and why its location and what are we trying to achieve?
Well, going back over a little bit over the history, we've done just over 6,000 meters of drilling on the project. That's in 33 holes. So if you do the math, it's pretty shallow drilling overall. And we've been drilling basically from near surface mineralization and following it, for the most part, following it down dip. We've been pretty successful at that. And we got to a point, we're about 75 to 100 meters below the surface vertically. And then we can't drill from our concession and get a good angle to cross the vein. So that's where the idea with drilling from Visa ground is. And we're drilling this first hole particularly because it's a 50-meter offset down dip from our previous drilling. And it's from our 50-meter offset from our best hole to date on the project, which was 102 grams per ton gold and 3,100 grams per ton silver over half a meter. That's about 11,500 grams per ton silver equivalent assay. So we're drilling down dip from that. That was on a particular structure that has higher gold to silver values in it. So, we'd like to offset that and then continue on and cut the main Palos Verdes vein, also about 50 meters below previous drilling.
Do you expect there is going to be grade continuity at depth? I mean, do you think these grades could continue with depth? Because this is more shallow stuff that you're going after. But what do you think?
Well, in the past, our historic drilling there is, it's been pretty continuous from the surface to 100 meters. And, the Vizsla Silver's drilling, particularly on the Napoleon vein, which is very similar to Palos Verdes, has shown vertical mineralized intervals of 250 to 400 meters. So we would hope to have some more mineralization at depth. The truth machine will tell us here shortly, but I think the continuity of the vein will be there. There's not much question about that. And then the grades, we'll see what they are. These types of systems commonly grade from precious metals rich to base metals rich with depth, but I don't think we're quite at that depth yet, but we'll see with this drill hole.
Is this a challenging target, though. I mean, Palos Verdes, as far as I understand, is located on a faulted structure with at least, what is it, three distinct veins. Well, I mean, do you expect any potential disruptions in the mineralization that might be caused by faulting or anything else that's happening, making your life more difficult?
Well, I think, we've said several times the vein itself is faulted into two blocks, two principal blocks. The one in the southwest corner of the concession is on the west side of a northerly trending fault. And that part is, we've drilled a lot on it. We know the orientation of the vein, and we've actually modeled several subsidiary structures. So we hope to be able to trace those, 50 meters off of our previous drilling. But the complexity comes when we go to the northeast or the eastern side of that fault. We think, based on geology and alteration mineralogy, that the northeast part of the vein has been down dropped considerably, maybe 50 to 100 meters. So in the past, when we've mapped on the surface very narrow veins and veinlets, they have some silver values in them, but they're narrow. Very similar to actually what Vizsla silver had it at the start at Napoleon. Not very impressive structure at all at the surface. Small workings, virtually no formal production from that vein. And underneath it, there's a very large resource drilled out. So that these things can open up at depth, and that's what we're hoping happens on the east side of the fault. So that's our second part of the first phase, is to drill and test for that down drop portion of the high grade ore shoot on the eastern side of this fault.
So you think that the eastern side of this fault is the one that has the most potential for, again, high grade, but not only high grade, because in Mexico you want, well, overall in the world, you want it to be high grade, but continuous high grade and continuous widths as well. And that's the eastern side of the fault that you think that's going to give you that?
Well, technically, we have that on the west side, and we're following it to depth, and now we're looking for it on the east side. And if we're successful in finding it, it opens up everything, because the western part is pretty much, we've drilled enough to know what's there. It's just now depth potential. The east side is all open, and it could be much larger than the west side. And that's the key, is drilling that off and finding it and being able to drill it off, not only right near the fault, but all continuing to the northeast. We have about a 750 meter strike length on the vein on our concession, and we've drilled really technically only about 300 meters of that. So, we've scratched a little bit on the rest of it, but we really haven't done anything significant at depth. And that's the goal of this program, is to basically finish the program that we started in earlier phases.
How is that program going to be split again? 1,250 meters is what you're planning on drilling, east versus west. Is there a percentage breakdown that you can give me now, or is it kind of a see as you go type of approach?
Well, basically the planned drilling is a 3,000 meter program. And what we did, we set it up to drill the first part of it as about 1,250 meters in probably 4 holes. 2 of those holes will be on the western side of the fault, drilling down dip on the mineralization we've already defined. And then 2 holes will be on the eastern side of the fault, exploring for this down drop portion of the vein. And based on the results of those, we could vary our program on drilling either on the west or eastern side of the fault with the rest of those meters in the program. So the idea is to see what comes out of this first part, and then take a step back and see where to put the rest of those meters based on results.
You mean we're going to get the 3 doctors in geology to get together and figure out what those holes tell us? Namely you, Peter McGaw, and Jesus Villador, who's the VPX of Vizsla?
Yeah, that's kind of what we've done so far. We've got everybody together and looked through the program, and so that's kind of what we do.
I thought you were referring to me when you say a doctor in geology. Are you?
You're a doctor in communication, Antonio.
I wish. And definitely not if you ask my wife, pretty much the exact opposite. But so are you going to be
Oh boy,
doing any downhill geophysics, or do
we
you
could
want
do
to?
an hour on that topic.
That is true. Maybe we should start a separate
Maybe another
podcast
day.
though. I want to talk about geophysics though. Are you going to give create the a little bit of rope to do downhole geophysics? I know geos like doing that, but I mean, Craig, do you want to do it, and are you going to do it?
This type of a program and target, we're not going to get much out of geophysics, at least for the looking for the target we have right there. If we suspect there's something, larger at depth, we could do that. But right now we have no plans to do geophysics. So it's a very discrete target, a particular vein system. So if something happens on the northeast side of the fault and we don't hit what we're looking for, that might be a point to say, okay, maybe some geophysics will help us figure out where that is. But at this point, we don't really have that in the plan.
Hmm. How are you actually going to trace that displacement? I mean, if that's the case, you don't quite know yet, but you've mentioned again a cross fault may have displaced the vein system kind of to the east. How are you going to, if it is, how are you going to trace it on the back of it? Is it, I mean, part geophysics, but what else?
Well, with what we've done so far is, we know there's a fault there. You can see it. It was mapped from when we first did our first program there, mapping at 2017. That was recognized and it was mapped. But it's a fairly wide structure with a lot of ground up rock in it. So it's kind of hard to tell what's going on within the structure. We've drilled across it a couple times, and we know based on that drilling that in the hanging wall side, we say, or the down dropped block, we have some alteration mineralogy, which on these types of vein system is suggestive of being at higher level than what we see on the west side, which to what basically it means that those minerals, clay minerals particularly, formed closer to the surface than what we see on the part we've already drilled.
Hmm.
So that suggests to me that the eastern part of the vein has been downdropped. Some of those original high level minerals that were eroded off the western side have been removed by erosion, and on the eastern side they're preserved. So that gives us the idea that the structure that we know is there, you can see it cut the mineralization off, and that gives us the idea it's downdropped, it's moving downward, and it looks like a significant distance because of this preserved alteration mineralogy.
Hmm.
So we think it's on the order of 50 to 50 plus meters, and so our goal is to drill that depth below where we've drilled before and see what we come up with.
That's interesting. That would have been one of my follow up questions. But it's good that you understand the alteration package. Is fluid inclusion studies or isotope work or something else that you're going to have to do on it on the back of this drilling?
Well, I'd like to do the fluid inclusion work in general because it's a multi-stage vein, complex mineralogy, and that always helps you determine where you are in a hydrothermal system. But at this point, we don't really need that. We need, basically drill intercepts, visual confirmation, and actually used a spectrometer to identify the clay mineralogy in the core. So, I think we've done what we need to do, and now we need to get the actual data points from the vein, which is what this drill program is designed to do.
Hmm. Well, why I'm asking really is because I'm wondering about the again width and width continuity, because I know Wiesel did a lot of work to ensure that they have the right width, because you can have a lot of high grade in those type of systems, not necessarily always the right width. So what does your current model tell you about width picking up a depth or across the package? Is there any expectation? Is there anything you can know about the width of the veins by
In
just
general,
looking what you have now?
yeah, I mean, in general, we've seen the vein get a little bit wider with depth, particularly on the west side of our drill program in last year, actually the year before. So we got some really wide intervals, but unfortunately, in those holes, some of those were late stage quartz dominant mineralogy that really didn't increase the grade too much. We had some pretty good intercepts though, and I think we'll see wider intervals at depth. Can't really say much about those until you drill them. And I think, using, I mean, we've sat down with Visla, Peter McGaw, and also with Jesus Villador, looked through their program, a lot of the work they've done. We use some of that to focus our our data gathering program to design this drilling. So I think, at this stage, we've used a lot of the more scientific data that we have available. And basically for continuity and widths, the drill will tell us that. You drill closer, and the continuity, you'll get that out of it. You'll closer space intercepts gives you a increased confidence on the continuity of mineralization. And we haven't done that quite yet at Palos Verdes. So that's one reason we don't have a resource. We haven't really focused on drilling off a resource. We're still following mineralization at a little bit more larger scale. So, and this program will take us to that level.
You've also mentioned that the veins kind of split at certain spots, so some of them have a higher concentration of heavier metals. Also, some of them have a higher concentration of gold than silver. And so, do you think they would rejoin at depth? Like, do you think that's what's going to be adding to the width?
Yeah, I mean, epithermal vein systems commonly have a lot of splits like this. That sometimes they do rejoin. They're called sigmoid loops in that case. But this one, I'm not sure if they're gonna rejoin at depth. I've seen it happen in other places. This one, we're just happy to have the high grade mineralization. It is, we could see it before. It was probably a separate stage of mineralization, and I think Visla Silver's data has shown that in the past. In some of their original drilling at Napoleon, that they had pretty similar grades, and all of a sudden they had 100 gram per ton intercept. And at that point, I said, well, we should have that also, because we are virtually identical paragenesis or mineralogy in the two veins. If you look at them in the pieces of core, you could probably not tell which one they are if they weren't labeled. So, I thought we'd hit that. We did hit it in the last program. And, the higher gold silver ratio vein, it's not necessarily higher gold values everywhere, but it's got more gold for the proportion of silver. So it's an interesting stage to have. And when it gets, high grade, it's, 100 grams per ton gold is a significant intercept. And that's always welcome to have.
I think that's enough of me pretending to understand what's happening with the geology here for a second. I want to talk about this terrain on the surface, because again, that's part of, as far as I understand it, part of the delay that we discussed earlier, Alain. But how have you been down on a project? How challenging is this terrain?
Well, Alain, has some comments at this. Usually I'll let him take this at the start anyway.
Oh, yeah. Well, yeah. So one of the reasons, Antonio, we added the pictures and videos to the news release, explaining that what had taken place in the last 4 weeks, so that people could see how rugged the terrain is, and basically it's almost like we're drilling off the side of a cliff. Craig's there on a regular basis. And I'm pretty sure you're heading back there soon, probably next week, Craig. And you want to expand on Antonio's question?
Yeah, well, part of the thing, this, having to drill from man-portable equipment, but it's got to be equipment that'll do, the 500 meters planned for the deepest hole. So, it's a drill that's very powerful, but the motor is even set into three parts. So they're to make it man portable, right? I think they're 50 kilo pieces to the motor, and then they join them all together with hydraulic hoses and everything to make a powerful system. And so all these parts have to be brought in by hand, and we had to make a trail that's safe to walk on and wide enough for this all to be done, which we did that first. And then this drill pad, the first one particularly, was on a steeper slope than we actually had originally envisioned. So it took considerable effort to make a flat spot that was 5 by 5 meters which is what we need for the drill and the ancillary equipment that goes along with it. So it took a little bit of time to put that together. And right now we're actually constructing the path and the pad for the second site, which is a much easier site. It's about 70 meters away, horizontally straight line from where we are right now. And it's a little bit easier site. It's much flatter. It'll probably be done here and well before this other hole is done, so we won't have a delay there.
How are there any limits or challenges to this being a man portable drill, or at least that's what you call it? I suppose depth doesn't matter because you're not drilling too deep right now, but timing, efficiency, cost, is there any other limits to it?
Well, efficiency is a little bit down because everything has to be brought in. Once you're drilling, like we are now, you can bring steel in as you're going down. It doesn't really cause a delay. But the initial setup, there's a delay transferring all the gear and getting it set up. It's a little bit longer than a truck or a track portable drill site, which you pull the steel out of that and you put everything on a truck. Run the rig over on a track and set it up, and you could be drilling again, that same day or the next day. In this case, there's a little bit of lead time in moving everything and downtime at the end of the hole. So, taking core from the rig to the truck to take it to the core logging facilities, that's a little bit different story. And I saw Wiesla actually in our visit there had a mule there with a special setup to put the core in and take it up the hill. And ours is pretty flat. We probably have guys carry it a couple boxes at a time, but we always have the option of getting a mule helping carrying gear also, going back to the old days.
Well, again, to bring up my loving wife again, if you ask her, there's no difference between men and mules. So that's going to be interesting to see if you actually get a mule to carry. What you say, efficiency might be a little challenged here. When do you think you're going to have results? How many meters are you getting out per shift? Talk to me about timing.
Well, we envision same as other programs. So the rig is powerful. It's a good rig. It'll be 15, 25 meters a shift pretty easily. And, with any luck, we'll get a bit more than that. So we're talking, 10 or 12 days for this first hole. From now, I'd say probably less than that, but, 2 shifts and everything going on. And then, as the core comes out, we're logging it. So, we don't have much yet, but, as soon as we get, a few boxes of core, we start logging it. So we're always logging it, marking it, and sampling it. So when the last box comes out, we're already, half done with the hole in terms of logging and probably actually sampling it. So there's the downtime, or probably not the right word, and lead time isn't quite it either, but the time at the end of the hole is not all that much. Once that hole is done, within a week, we're probably sending it off to the lab. And I think
Craig, you might want to mention that we'll send it to the lab in locally, right? Which has some pretty good turnaround times.
Yeah, we use a very reputable lab, one of the best labs in the world, SGS, and their lab in Durango has given us great service. They come down to the site, pick up the samples, and then they take them to their lab, which is about 4 hours away. It's a nice highway there, and then they prepare everything in that lab. But in this case, they actually do the assays in the lab. The analytical work is all done in their facility in Durango, so it makes it much quicker turnaround. They prepare it and analyze it right there. And some of the labs don't have that capability in Mexico, or only partially. So they prepare the sample and send a 200-gram pulp to either Vancouver or the States to get it analyzed. And that's a little delay there. And then those facilities also receive samples from everywhere else. So there's a backlog. And this lab is, it's much easier. It's much quicker for us. And they've given us, great results and great work in the past.
And Alain, do you want to release this kind of in batches or just release it as it comes all at once, one by one? Talk to me.
Yeah, so that's a very important question, and let me answer it comprehensively. So, on our team, if let's say you go to Dr. Peter McGaw, Peter would favor getting all of the assay
Mm.
results, analyzing them, trying to comprehend what they're telling us, and then come out with one news release. So that's sort of one approach. That's been his favorite approach. Now, he is involved in uh, large exploration programs larger than what we have here, and then you have the other end where do you really want to release hole by hole? That might be a trap, really. I remember when we drilled the east side of the fault, and we saw some high grade veinlets, and everybody was scratching their heads. And we could have said, well, why don't we release those results? But we didn't know what those results were telling us. So we actually did not release those. We did geochemistry and all sorts of surface work. We went into the VISLA database and look at what we could learn from what they learned when they encountered something like this. And after we did all that work, then we released the assays for the hole, the drill holes, and the geochemistry, and then we had a comprehensive geological theory that we could explain. So, sort of I'm telling you the sort of our philosophy here. Think it's okay to release one hole in the first phase. People are anxious to find out what's there. So are we. And it's been drilled. We drilled most of the 6,000 meters has been drilled on that side. So it's just additional information of a well understood system. So I would not be against releasing hole number one as a standalone.
Mm.
I'm not committing to it, but
When are you targeting to have it out by that hole number one again? I think, well, before the end of the year, I hope.
oh yeah. So what, 10 days to drill, and let's say 2 weeks max to get the assays.
Oh,
Is
so a
that a
month
fair
from now,
estimate, Craig?
basically.
Craig, do you think that's fair?
Yeah, I think a month from now we could have some results.
Nice. Okay. Good. Do you think those results, not only that you have coming in about a month, but in everything thereafter, and of course, if this is a big if, but if the drilling is successful, do you think that's going to be enough to get you to a point where Vizsla wants to take it off your hands and have full control over it? Is this the year that we see that happen? Can it happen? Talk to me about that.
Yeah. Probably not the year as in 2024. So yeah. I'm not in Mike's head, Mike Connor, but him and I do have a great relationship. He's a great guy, smart guy, and we will be talking, I'm sure, as things unfold. If you look at uh, if I'm him, I'd like to get the ounces, I would think, early at a discounted price. If I'm me, I'd probably want to have more ounces, so which means more drilling, and try to maximize uh, the sell to Vizsla. Now that being said, we're realists. It will be what it will be. Given what we see, and if we're successful in achieving the objective that Craig has um, described in this video, it's going to be accretive to us. It's going to be multiple of our market cap, and so we'll see. I think it's more likely a 2025 event than a 2024 event, Antonio.
Yeah, I should have said this season, not this year. So that's a very good
Okay.
point.
Yeah.
Yeah. Are there, maybe we can talk about cost at this point. That's going to get us into talking about hot bridge as well. But how much is this going to cost you here?
Go ahead, Craig.
Yeah, so roughly, we're at this program, we're looking at about 200, between 200 and $250 a meter for drilling. So you can calculate the 3,000 meters or 1,250 meters, and that's pretty much all in. That's all the assays, all the geologist time, and everything else. So we kind of use the 250 and hope to come a little bit under that. In the past, we've come in well under that. This program, it's going to be a little bit more expensive because of the hand moving and things like that. But I think we'll be around that cost. So you can do the math there, but it's not a huge program, and we have the funding to do that. That drilling right now, that's not pending or contingent on financing.
How much money do you have right now?
Well, we got enough for that and for our G&A. Which is, as you and I have discussed before, quite flexible in the sense that nobody's on a fixed salary. So if you want to get paid, you got to do some work, and because most of the senior people we have are geos, so then most of our expenditures towards their work is for geological work. What we do need to finance, Antonio, is the drill program at Hot Breccia. I think you and I have talked about this a little bit. So we're planning 5,000 meters of drilling. Let's say 5 holes of 1,000 meters, could be 4 holes of 1,200 meters. And that's a $2 million US ticket item, rounded up to 3 million. So Steve and I have been quite busy talking to investors. We were busy all summer and trying to narrow down the structure of how we want to do this, exactly when we want to do it. I think that the time is now, really, and pretty happy that our share price reacted to the recent news. So I think we're in a favorable financing environment for the upcoming Hot Breccia drilling.
Right. Oh, and then just to clarify, everything we've talked about so far, me and Craig here, was the Mexican assets. This is not your flagship asset. This is for people listening. The flagship asset isn't Arizona. That's the Hot Breccia asset that we're talking about, which I also assume is what attracted most people to the story. Yeah.
Antonio, can you define flagship for me?
Well, no, I was hoping you can do that.
That's a tough
Okay, well, let me say this. It's just we're joking around. Antonio and I get along very well. So let's look at it this way. Why do our stock react well to positive news regarding Palos Verdes? And the reason is that let's call our legacy shareholders, the largest portion of our shareholders, probably bought in based on that asset. So anything that we do that advances the asset, they looked upon as being favorable. And then in terms of upside, people have been quite well educated on the Vizsla story, right? And then Vizsla has made incredible progress in the last few years. So when we were drilling in 2022 at Palos Verdes, Vizsla was not where they are today. So there's, I would say, a lot of knowledge about our asset at Palos Verdes by our shareholders. And then the Vizsla story, as evolved and is better known, has given people a better appreciation for the potential at Hot Breccia. So I think that's the context upon which we should look at what's going on in Mexico. So if you look at the Hot Breccia, that has clearly the potential to be transformative, and because it is a big target in terms of sheer size and potential economic value of it, while Palos Verdes has great potential. I think we're looking at multiples of that in the case of Hotbrecha. So I guess from that standpoint, you could say, yeah, it is the flagship. And as you were saying, I would say that the most recent shareholders, including a private placement we concluded in June, yes, you are entirely right to say that the new people were attracted to Prismo metals on the back of the Hotbrecha copper project in Arizona.
Well, I want to talk about that and get a bit more specific on the timing there, because I understand it is financing dependent, but when would you like to have it drill? Like, what would you consider success if we're talking in 6 months and it's not yet drilled? Are you still going to be happy? If we're talking in a year and it's not drilled, are you still happy? Talk to me about that.
It will be drilled. I would say we'll have a drill on site in the next month or so.
Okay. So the computation phase there is completed, I assume. You know what you want to drill. Maybe you can talk to me about that as well.
So we did. So two significant things happened since we last spoke. So we did get phase one computation results of the artificial intelligence, and then Craig and Steve gave their feedback as to what the initial results were, and they reran certain things based on their input. And I think we have a call with them tomorrow, so we'll learn more in their phase.
Okay, and
is that we acquired information about, well, we got all the information we need for hole number one, which we did not have back then. So, so you might want to expand on that.
Yeah, I could talk about that. We acquired a data package that was generated in the 70s, particularly from 72 to 74 or so, and that included the entire drill log for hole one at Hotbrecha. And we just had the top of the hole and a reference of an interval. I think it was 0.54% copper over 77 feet. And now we have the entire data package for that hole, and we can see the assays that made up that interval, but more importantly, we can see the assays around that interval. And that interval, if I'm correct, started at about 2,100 feet, but the mineralization started above that and actually extended to the end of the hole. So that interval of higher grade mineralization is surrounded by an interval of lower grade mineralization, which is important. It's not constrained by 77 feet. It's extending over several hundred feet, and it's not high grade, but it's showing the mineralized system is large. And we suspected that in the past, basically because the underlying property owner, Dr. Linus Keating, saw the core, in the 90s. He looked through it and actually sampled some of it for other purposes, but the core is not available anymore. He saw it. He knew it was a large mineralized system based on what he saw, but none of us have seen it. So it gave us a little confidence boost that everything is the way we think it is. And I think the other really important part to me is that the geologist who did the thesis on the property before it was drilled, Larry Barrett, he did mapping and did a model for the deposit before it was drilled, and then he was hired by Kennecott and actually was on the drill. So he had his model and he saw how to modify it based on the results, and he wrote a summary of the first three holes there. And really the only one that's important for what we're talking about is hole one. And he modified the model of mineralization based on what he saw in hole one. And the critical thing, he included the causative intrusion, basically an intrusion that came in and produced that mineralization that we see both in surface on fragments and in those historic drill holes. So in the past, we had skarn and replacement mineralization in favorable carbonate rocks, similar to the Christmas mine, which was a good comparison nearby. But that's all we had. So we can hypothesize, well, there's a porphyry there. There's some intrusion that caused that mineralization. well, that was described in hole one, and we didn't have that data before. So to me, that was we have not only the high grade target that we initially had and we have been looking at, but we have a large tonnage or large volume, potentially, lower grade target there, which would be the porphyry deposit itself.
It's that's something Steve and I have talked about before as well. I believe in our first conversation or something along those lines. So that's it's definitely going to be interesting to see. First of all, to see what you come up in terms of drill targets and what exactly you want to drill, and then obviously what comes out of the ground. But you're saying you're going to have a drill on site within a month, a month and a half from now, Alan. Are you going to do a news release on which targets are getting drilled exactly on the back of that computation phase? I know you're using a little bit of AI as well, so maybe you could talk to me about that.
Yeah, I think that's very important, Antonio, right? Because retail investors have been conditioned to read headlines and look for fancy headlines that catch people's imagination, certain percentage of copper over a certain width. And that might impact market price, right? We've seen it, we live it, that's the world we're in. So I think it is very important to, before we start drilling, to explain what we will be drilling. And we did the same thing with Palos Verdes, right? So there's the west side of the fault, here's why. And then we're going to move slightly to the east side of the fault, here's why. And then we're going to move up to the northeast. So people have a good understanding of what we are doing, but also why we're doing it. So we will absolutely have a comprehensive news release announcing where we intend to drill and why we intend to drill where we intend, and how we might also change the drill plan based on what we see hole to hole.
Okay. When do you expect? So that's going to come before you mobilize the drill?
Yes,
Okay.
yes.
Yeah.
So I'm looking forward to chatting with Steve and Craig, Peter McGaw, and I'm sure we'll invite Linus Keating, Dr. Linus Keating, and I know that Craig and Steve have been talking to some people that have been that were involved in the discovery of resolution, and so we're going to have some pretty good brain power putting that drill plan together. And then my job, Antonio, and yours will be to explain it to investors.
My job will be to try and understand it first, I suppose. So that's actually a good point because this um, drilling preparation phase, if you will, the science phase, as I like to call it, involves a lot of desktop work, which from a retail investor perspective can be boring due to the lack of meaningful updates. And when I say meaningful updates, I mean really just from the layman's perspective. Like me, what's meaningful to me is assay results or like, okay, we're drilling or financing. So stuff like that. So do you think that phase for you now is kind of, well, it's coming to an end, and I suppose the more meaningful news releases are going to start coming in a more consistent cadence from here on. Is that kind of how you see it as well?
Well, I like to describe communicating the story of an exploration company as putting a Netflix series together, right? The Netflix series, you kind of know what's happening this season, right? So, and then you have certain episodes. What you never know is how the series is going to end, right? And then if it's going to be a cliffhanger, and then you don't know if there's going to be another series next year. And so for us, we know what we want to drill, we know what we want to achieve. We're gathering additional information through AI. We bought some additional geological information, and then we need to put all the brains together and make sense of that and debate what's the best approach. If you talk to a retail investor who's seeking to make money overnight, not over time, they're going to say, well, why don't you try to drill, the sweet spot of the thing? Where's the sweet spot? And try to hit the sweet spot. I already know my guys are not going for that. They're starting to gain geological information. And so we will have to explain that. And And if you look historically, Antonio, we like to communicate. We like to tell people what we're doing. We like to tell people what we're seeing. And so we will be communicating about hot breccia. Well, just imagine, right? So how much communication we'll be able to generate out of drilling hot breccia, given its significance and hasn't been drilled in 50 years, and all eyes on that prize for sure.
Hmm. What else is happening in the meantime? I mean, you're out there a lot. Yeah, I see a new interview or something else every week with you or Steve or Dr. Gibson. But what else are you doing? You're going to conferences or something else? I believe you told me a little bit about that. You kind of want to divide and conquer, so be at different conferences at the same time. What's kind of the plan for telling the story now that you're moving into a different phase of the exploration process?
Yes. So let me address the first point, which is communicating, let's say, once a week. So I've been in this business since 1987. And one thing I learned quite early on was that it's easier to retain a shareholder than to find a new one, right? And if you convince somebody not to sell your stock, you give them a reason not to, it's just as important as finding a new buyer. So we like to communicate with our shareholders, keep them informed. And another thing I learned is people want corporate updates. And back then when I started, there were just telephones and not even a fax machine. So you had to pick up the phone and give business updates. And if you wanted to talk to 20 people, you had to say the same thing 20 times over the same thing. Now we have the internet and we got people like you. So we like to do corporate updates and put it out so that our shareholders always have the latest. And then the second part of your question, well, we also work on getting new shareholders. So we do like to attend conferences. We were at the MIF in Vancouver, Craig and I, last Friday and Saturday. I met a bunch of new potential investors. We made a presentation to, probably 100 people. And now we're going to go to the Manuel Bali conference in Zurich. So that will be Steve and I attending that. And Craig and a colleague of ours is going to attend Brian Lundine's New Orleans conference. They happen to be on the same weekend. So yes, divide and conquer and tell the story. And I'm also going to continue to be on the road meeting retail investors. I'm actually going uh, back east next week, and I'll be in a wonderful part of the world called ABTB. Lots of nice gold companies there, and I'm going to be there for 3 days meeting retail investors, telling the story.
Interesting. Interesting that you're going to the Abitibi in Quebec, going back to your roots, I suppose. So do your French magic there, I suppose. I joked about this at the beginning though a little bit, Alain, and your stock has been going up. I mean, I think since last time we spoke, you're up 25%, something along those lines. There was some nice volume over that period as well. Yeah. Who's buying is what I want to ask you. And maybe you don't know exactly, but you're out there telling the story. What is your gut feeling telling you? Are you getting some new strong hands onto the story? Who are you placing shares with?
So here's the thing. Remember this, Antonio. If I don't know who's buying, it's a good thing, right? So if I know everybody that's buying, that's not necessarily as good. I would say that so who's buying is a combination of people who have listened to our, well, let's say people from the conference. Before that, Steve and I were on retail roadshows. We went to Quebec City, we went to Montreal, went to La Beauce, and I know that generated some buying. There is a well-known, very well-respected mining analyst, Eric Lemieux, who has been starting to, and you know him, and you'll be with him at the conference in
Yep.
Zurich. And Eric has started to write about us. So I think that his followers have started to buy our stock, and then we continue to be very active on social media. We got a lot of content on social media, and we follow the progress of that month to month. Big shout out to Anya and her team in Mexico City. They do a wonderful job, and we follow the sort of the growth month to month, and I think that's generating also a lot of interest among new shareholders.
Good, good for you. It's not all free though. I mean, you have to make sure that the money is going into the right spots. What are you budgeting for G&A going forward? Are you going to be ramping up marketing, keeping it where it's at, or cutting back? Talk to me about spending.
So the hard G&A, which are the company costs, are about 350 a year. So that's what, lawyers, listing fees, and CFO, auditing, all of that stuff. And then everything else is discretionary. I do want to say, when you say, well, like I talked about social media, and you mentioned cost, which is a good reaction on your part. What I really meant is our social media stuff is organic, right? So we have this team in Mexico City that manage our website and all our social media channels, and they're very affordable, and they're some of the best I've seen in our business. And then we like to travel. We like to meet people. We're kind of the old-fashioned way. So you won't see a news release from us saying that we've decided to spend €500,000 in the next 2 weeks on whatever, emotional thing. I'd rather do things the hard way. It takes more time. It takes more work, which is to try to convince people to buy the stock, and based on fundamentals, and hopefully they keep it for more than 24 hours.
You shouldn't convince them. You should just make them buy the stock. But no, this has been a good update, Alain and Craig. Thank you so much for sitting down with me. What am I forgetting to ask you though here at the end? What do you wanna talk about that I'm failing to bring up?
I think we covered it all. Craig, did we forget anything?
Well, I think you did a pretty good job of covering everything.
Good. Good. Well, thank you so much for doing this. This has been a pleasure, and hopefully we'll do an update soon.